to listen from him. So he has the background of how LSP started and where we are. But we need the future direction. So welcome, Raghu.
Thanks, Ravi. Thank you. Yeah. Good morning, folks. Welcome to Mintra. We're happy to be hosting all of you here for a fairly momentous uh, version of LSP, the 50th version. And thanks to Debanshu and Ashutosh for inviting me. It's definitely be a pleasure to be here. So I think the organizing committee, I don't know who all they are besides Devanshu and Ashutosh. I mean, obviously have taken a lot of effort in organizing this. This is the 50th one, and from what I hear, it's there's been no break at all, right? So it's like every quarter without fail, and it's amazing commitment. Hats off to you guys for doing this. Certainly great for the ecosystem, right? And obviously DevOps is super important, for maturing of the product development ecosystem in the country. And again, kudos to all of you for taking time off, on a Saturday morning. And I think probably some of you had a long weekend as well, with yesterday being off for some, and making it here. Some out of town as well. So certainly, huge commitment from all of you, and great to see that. Another thing that I noticed was, the distribution of people, right, from startups to like GCCs to consulting across the board, right? So it's really great to see representation from all these various, domains, and also obviously from DevOps. But I saw, engineers, architects, data scientists, a good mix of representation from across kind of disciplines as well. Obviously, DevOps touches all aspects, of software development, and super important. So it's great to see, a great representation from across disciplines, and certainly shows the appreciation of DevOps, for amongst, between all the areas, right? Um, so I think DevOps obviously is not new, but we've seen a lot of innovation in the last few years, and primarily driven by cloud, right? So cloud adoption, and I would say maturing of microservices and service-oriented architecture, which made things so much more modularized, ability to scale horizontally, independent components. And all of this introduces huge amount of complexity, and which is where kind of DevOps plays such a huge, crucial role in making sure systems run smoothly. They are, monitored, all the alerting, observability, scalability, reliance, everything, right? Reliability. So everything comes, makes it more complex, and that is where this, DevOps has matured so much in the last few years, whether it is just CI/CD or, serverless computing, the whole Dockerization and, containerization orchestration, which is Docker and Kubernetes, the, infrastructure as a code, the Terraform Ansible, and now extending to GitOps as well, right? So making it more integrated with Git as the repository. So many changes, and it's the discipline has really matured. And given the boom in our own startup ecosystem, which is, we have a great representation here. So this is, again, contributed heavily here, right? So where we're building large scale platforms, right? Reliable, low latency, large scale platforms in the country, not only to serve the millions of users within the country, and of course for global. And this has been, this discipline has helped, that whole acceleration of that process where, companies are relying on the talent here to be able to really get products developed out of India, right? Going way past, our humble beginnings of consulting work. So obviously DevOps has played a huge role in maturing this whole, process itself. With each influx, or what I would say, inflection point, I would say, of this technologies, I think it gives is a great opportunity, right? So like the whole cloud adoption was the last big inflection point, and which spawned so much of innovation and so much of a need, and which was filled. So the next one obviously is AI, right? Of course, AI has been there forever, as we all know here, but it's become more and more mainstream with Gen AI, which has truly democratized certain aspects of AI, right? So now that this has become so much mainstream and being adopted widely, and with engineers being able to develop AI-based systems relying on LLMs or LIMs without necessarily the need for data scientists, which is a valuable skill, right? So now we can see AI-based systems really kind of becoming very, very prevalent. So in Mintra, we've been using AI, for the last 7 years across the value chain, whether it is our own like trend identification. I mean, Mintra, as hopefully all of you know, is one of the premier fashion and lifestyle e-commerce platforms. And we cater to the fashion forward or the premium customers, right? So who look for trendy clothes, who look for fashionable clothes, and so which makes it very important, first of all, to identify these trends, right? So what is trending and what to take bets on, right? In terms of once we identify trends. So we start with AI there. So since I'm talking about the new wave as such, so we've been doing this, and I'm just trying to give you a flavor for where we use AI and where we are going and how I foresee that, for DevOps, I think that's the next big inflection point on how things will change, right? So like I said, we've been using AI across the value chain, starting from the sourcing part, which is the trend identification, demand prediction, purchase order creations, pricing, and so on, right? And then we also have our portal, partner portal, so all the insights that we do, from a data insights point of view. Again, we use AI for our own customer experience, right? We heavily use AI, whether it is personalization or it's different aspects of search, including auto suggest, ranking of results, computer vision based, image search, or even the post purchase journey, in terms of route optimization and so on across the board, right? And of course, a lot of companies have been doing many of this. What we've done is recently launched a couple of features using Gen AI, right? Which is where I think the world is moving towards using Gen AI, more and more across various aspects. So we launched something called My Fashion GPT, which is for natural language searches, and where we saw like a fairly good percentage of our searches are where people are using natural language, and we were like underserving these searches, and there was a higher query abandonment rate, right? So once we leveraged LLMs for query understanding, user intent understanding, and then using our own vast catalog database, we're able to serve relevant results, which really dropped our query understanding. Sorry, query abandonment rates, right? So various use cases such as these, then we extended this further to what we are branding as Maya, which is our conversational interface. So which is basically, it acts as a shopping assistant. I think Amazon has introduced Rufus, right? And something similar to, the My Fashion GPT, so which is integrated search, which also has conversational capabilities, which is a new interaction paradigm, companies are experimenting with, where you're trying to recreate the experience of a shopping assistant online, right? Saying you would go and say, okay, yeah, I want to go to a party this weekend, what should I wear? And then, the assistant helps you narrow down your choices, asking you relevant questions and so on, right? So many different use cases, for Gen AI. Using Gen AI makes it easier to implement, I would say, in Gen AI, right? So this is going to become more and more mainstream. So which brings about a number of interesting opportunities and challenges, right, for DevOps. Um, So I would say, first of all, now we have like so many more infrastructure components, right? Both external and internal. So how do we now, bring all of this into the, into the ambit of, monitoring, alerting, and deployments, and so on. What new challenges that bring this could bring about. So then, of course, there is this whole security aspect to it, right? I mean, anyway, there was a trend towards left shift. So the whole DevSecOps really becomes even more important now, as we're exchanging large volumes of information and potentially sensitive information, even to third party or like cloud based LLMs. So this becomes again, super critical. Another huge opportunity I would say is, in the whole alerting monitoring space, which is I think what I think people are calling now AI ops, right? So which is how can we leverage these LLMs to help, in the alerting monitoring, how do you make better sense of data, right? With the, and then even make it more self-healing, right? Using, these capabilities that are now there. Or like when you're developing all your automation and tools, again, we can use obviously, Copilot and so on and so forth to help in this whole process. So many opportunities that are out there. And I would say, again, an exciting time. This is another inflection point, which always means exciting, a lot of opportunities and challenges, which I think are there, for the DevOps team. While so far, I would say this space has matured quite a bit thanks to initiatives like this, where there are meetups, helps build the ecosystem, and then help educate everybody. So based on what's happening in the rest of the world, this is a new space now and new for everybody, right? So now I think we have enough experts in our ecosystem here. So my kind of request and a challenge to all of you and in general the DevOps community here is how can we take the lead now, right? Grab this opportunity, which is actually new for everybody, and come up with new frameworks, new innovation to handle this whole now AI and Gen AI wave that is happening, where I see so many opportunities to innovate. So that's really what I had. Just wanted to share some thoughts and just meet all of you. So certainly, again, once again, thanks a lot for inviting me. It was a pleasure to be here. But certainly happy to take any questions that you might have.
Hi, sorry, not sure if there are questions from the room. If not, I'll take it on the call.
Somebody's
Hi. Thanks for sharing all the pieces that Mintra is doing, right? I think something that is, while we are talking about all things AI and LLM, I think one thing that is there at the top of everyone's mind is how do we manage data security? How do we ensure that even though the data is now being shared with all of these models, how do we ensure the right sense of security of it? So how would love to hear your thoughts on how is it being managed, and especially while keeping aside the PII data set, the consumer data set, even something as simple as, let's say, the alerting data set, that also is critical, right? Be it for regulatory aspects or even simply from competitiveness perspective. So what will be your thoughts on it? How should we be looking at it, and how should it be managed?
It is a huge challenge. Sorry, I didn't get the name. So a huge challenge, as you pointed out, which is where I think there's definitely opportunity for innovation, doing something different here. Uh, so with the flexibility that these LLMs and LIMs provide, I mean, it makes it so much more easier to use them, and also like Copilot, especially where you're now like the coding aspect, and you end up sharing code, inadvertently. How do you prevent all of this, right? So one is, I mean, there are various ways one can do it, where you take a very explicit or whatever approach to this, like having fine tuning your own, hosting your own models and fine tuning your own the open source model to your own data. So that means it's all contained. Or you use the RAG patterns, retrieval augmented generation patterns, so where you're not exposing some of your your own knowledge base externally, right? You're using in conjunction with, an external model. So various approaches one can do, but how do you, prevent some of this data from going out is still a challenge, right? Whether it is intentional or unintentional, right? How can you do that? So how do you sniff, the data packets that are going out and look for, sensitive information? That's probably where you can actually probably use LLMs for that, right? To be able to do that. Yeah, I mean, that's what I feel, but I don't know if people have done anything there, would love to hear as well. But this is a big, big concern. I mean, for me personally, um, dealing with this, and I'm sure it's a concern for pretty much all the companies out there. Yeah. Thanks, Anshu. Okay. Great.
Hello.
Thanks, Anshu.
Hello. Hello. Yeah, it's working. So, I mean, I know it's a broad question, but I'll just still ask it. So, with so many LLMs and like many observability tools also coming out, how do you go about deciding build versus buy?
Yeah, so there are various aspects to this. One obviously is cost. In fact, I didn't even touch upon cost in the important role that DevOps plays. Cost is now on top of mind, right? So actually, one of the people who our BizFin likes the most is Ashutosh, right? He's helped us save the cost a lot for our infrastructure cost last year. They're super appreciative of what he and his team have done. So yeah, so cost is a super important aspect. Is when you're making these choices, that is one thing, and of course it's all based on the use case, right? Whether you want to like host your own model and fine tune the model for your data. For example, our use cases, what we have done, we've not done that, right? So we've just used the open source model out there. And this has worked well for us because we are not, sending any proprietary information. The example that I gave, we are just, using LLMs and their world knowledge to understand the intent, right? So it's like when somebody says, I want to go to a Mehendi function, what should I wear? So it knows, what a Mehendi function is, what do people normally wear for something like that. Once we understand, get that information, then we can query our own database, right? So that way there's nothing proprietary. So in this case, not needed, right? It all depends on the use case, a combination of what the use case is, as well as the cost investment that is needed. But of course, primary should be security, data security. It should drive a lot of these decisions on how you use this.
So a small piece of generative AI, right? So there are other models like diffusion-based models.
Sorry, not audible. Sorry.
Hello. Hello.
Can't hear you. Yeah. Go ahead. Talk loud.
Hello.
Small bit of generative AI. There are other models being in the creative business. So other models in new product design in Mithra.
Yeah. So I mean, LLMs is the first one that was out there with GPT 3.5, right? Which is what we are using. And so far, it's been in the NLP space is really where we've been experimenting and using this. So which is where we started. We're using LLMs, right? So There, especially for, as you said, for a company like Myntra, which is very visual, right? So a lot of catalog, image rich, a lot of video content on a platform, so many other possibilities, that are there in the LIM space, right? So we're experimenting with some of that, right? So how can we, for example, reduce the cost of our catalog creation? So what we see in many cases for certain cohorts, people like uh, models to be shot or catalogs to appear natural. So which means, if somebody is wearing beach wear, it has to be a beach background, right? Obviously, it costs a lot for do a photo shoot at a beach, right? So, what if we can use AI to actually just do a green screen background shoot and then superimpose a beach background, right? And it's easier said than done, or at least it was all these, till now, where there used to be different kinds of issues in like images getting morphed, cut off and so on, right? So when we do this kind of a thing, so now it makes it a lot more easier with these models. That's just one example. Another one where we're actually using is kids photo shoots. We also carry a lot of kids merchandise. So we actually use mannequin shots, and then we actually superimpose certain set of kid models that are available to us, and then superimpose, right? So because obviously we don't want to use too many kids, brings its own sets of challenges and so on and so forth. That's another area we're using. So a lot of possibilities. Like we have about like some out 6 more or 7 more use cases lined up on how we can do this better. But yes, definitely a lot of possibilities. Yeah, go ahead, please. Yeah. So one thing that I mentioned was reducing query abandonment rates, right? So where we had people using natural language searches and complex searches, which are like above, let's say, 5, 6 words. And so for those cases, the query abandonment rate has dropped significantly. Another way it has helped us is cross sell, right? So we have, fashion, lifestyle, home, beauty products, so on and so forth, right, in Myntra. What we saw is a huge number of our users are buying only in like 1 or 2 categories, right? So there is also this awareness and discovery problem that we're trying to solve. So what we did is, in this example of Fashion GPT, in fact, I didn't talk about it. There's another, it was not using GenAI, but AI, which is My Stylist, right? I don't know if you've played around with that. It is about each user having their own personal stylist. So, if so many times I'm sure we've seen that, especially, I guess, probably the ladies who say, okay, now I have this particular shirt. Now, what do I wear with this? What do I pair? What do I accessorize it with? And so on and so forth. Um, how can I, and that is like, that's where like a stylist kind of a, input comes in. So how can we democratize this? How can we make a stylist available to everyone at scale, right? So that's what we did. So where we are, when you have bought something for an anchor product, it could be either something that you bought, something that you browsed, something that you can take a picture of from your gallery and choose. What can you pair it with and create looks? That's what My Stylist is. So both for My Fashion GPT, My Stylist, where we are showing either a collection of products or like looks in here. So we are now exposing the user to so many other categories. So what we saw is the cross sell, for this people using these features are actually gone up, right? So we see like, for the propensity to buy more than one category is like 18% higher than, the rest of the platform. So that's another kind of win for us, as well. So that's what we did. I think you've been asking.
Okay, so we'll take the last question because we're heading towards the end of the session, and it's Raghu speaking.
Yeah, I'm Niranjan. Uh, Hello, audible, right? So India is the most consumer of open source models, right, or stack wise. So does Mintra consider open sourcing their fashion data sets so that Indian companies can build similar to stable diffusion or similar problems you're facing? And most of the AI development is done through open community. So have you considering to open source some data sets so that Indian developers can build based out models?
Sure. So we've not thought about too much in those lines, honestly. So we have done our little bit for open sourcing of software. So for example, our some of our front end infrastructure, the assets. So we have a framework that we developed, which we open sourced. And we are in the process of open sourcing a couple of other platforms that we've developed. But the data sets themselves, no, as of now, we've not really looked into that. Probably. Right now, I think right now there is no plan, but maybe in the future, yeah. Yeah.
Okay, so I think with this we'll conclude the Q&A with Raghu, and obviously thanks Raghu for enlightening
Thank
us
you.
on this. Thank you very
Thank
much.
you. Thank you. Pleasure.
So we'll invite our second speaker, second talk, Mitesh and Timana. Mitesh? Yeah, please. Anshu, you there? Anshu, was there any other question on the meeting? Well, we are not monitoring it in case there are any. Okay, super. Thanks, Anshu.
Hello.
Hi everyone. Yeah, Today we'll talk about multi-cluster load balancing in Kubernetes. Myself, Tamil Vanan. Uh, I see a lot of faces here. Looks sleepy, sort of thing. Is it because of Shivaratri or because I didn't know that it was Shivaratri. My wife said you should not sleep last night, so I didn't have a proper sleep. If I know this earlier, I might did my some sustained task like upgrades or something so that I can complete those tasks. So yeah, okay. Can we next slide? So myself, Tamil Vanan, I have a total of 11 years of experience. Is currently working as a platform engineer in RCCM. Earlier, I was working in VMware. I have given few talks in other Kubernetes forums like KCDs, and I was part of KubeCon organizing committee for last 2 to 3 years. Uh, I have a keen interest in exploring and solving cloud native use cases and problem statements. Uh, Apart from my uh, day-to-day tasks, my hobbies are playing badminton. So I have participated in few district tournaments. So for 30 or 35 plus categories. So you can do reach me out on Twitter or LinkedIn. This is my handle Tamil HCE. So with that, I want to introduce Mitesh and to get started with that. Doctor.
Hello. Yeah, I am Mitesh. I worked with Yahoo, Twitter, Ola, and CRED. Now I am working as principal engineer at Arsatium, and I love like solving the difficult problem in simpler manner so that it will be usable for long number of years without any changes. And in my spare time, I generally play chess, badminton with my daughter, and you can reach me out at my LinkedIn profile or Twitter at Mitesh S. Jat. So, and I have presented around 5 talks in LSP. I don't recall how many times I've come to LSP, but let's like we are at Arsatium managing 22 Kubernetes cluster, uh, means total around 600 nodes, and these are divided into generally as in many companies they're like development, staging, user acceptance testing, and production. And we deploy more than 6,000 microservice across these 4 deployment environments. And there are more than 400 microservice in a production cluster. So similarly, what we have handled in CRED. So here we are like getting 1.25 million requests per minute in production. Screen. Yeah, is it visible? This Ethernet cable is there. Okay. Yeah. So today's agenda is like what is multi-cluster load balance in Kubernetes and why we are using it, and effective multi-cluster load balancing strategy, what we should follow. So like as we are a fintech company, we are having bases in multiple countries like US, Australia, Singapore, India. So we want our cluster to be available from multiple geologies. So that's why we want to like have idea of like why we should be having like in this multi-cluster load balancing. So that's what where we have researched and found out mainly three kind of strategies which we can choose depending on the requirement. What we, so we want to share our learnings and like it can help people. So if they want DR even, so not only like having multiple, so it helps in DR also. So like key networking constructs are like pod to pod communication without the need of proxy or translating the IP addresses. And the second one is the service abstraction, which group pods under common access policy, creating a virtual IP for transparent proxy client request to the pods. So it provides the translation layer like in transparent manner without to configuring anything much. So in that manner. And third, the exposing our service to the like outer world in such a manner that it appears as coming from a single location, but it is actually being served on multiple locations. So generally in Kubernetes, we have seen like there is an ingress controller which is behind the load balancer, which gets the traffic and distribute inside a single cluster based on the route defined in our ingress controller, route or host name based on host name. So there are two kind of approaches we can take. So this is the like service-based routing. So ingress controller, when we hit say our service one user.example.com. So internally it goes to the containers of user service. If we hit a device.example.com, it goes to device service or endpoint will be different slash user. Say our domain is common. And so there are two kind of routing policy can be used. And all these things are defined in like either gateway class or ingress controller related CRD of Kubernetes manifest. So all this routing can happen at L4 to L7 level, depending on what thing we are using. So like Istio, we can use like gRPC, HTTP or HTTPS because gRPC gives better performance than HTTP, but HTTP is simpler. And if you want MTLS between like containers, so Istio service mesh or Linkerd service mesh can be used. So these are actually three multi-cluster load balancing strategy which we are going to explain. First one is GSLB. So it is based on DNS. So here DNS actually knows about where to route the traffic if this service, say, as I said earlier, user.example.com. So user may, that service might reside in say cluster one. And so it can route depending on the like DNS name itself. So that is helpful there. It is very simpler and not intrusive and can be used easily. But yeah, there are certain disadvantages like TA. Not immediate switching can happen because of TTLs of DNS. Second one is service mesh based multi-cluster. So certain service mesh provides like multi-cluster deployment. For example, Google provides Anthos and Istio, Linkerd we can use. Third one is a CNI base where we want to pod communication also like pod in one cluster can communicate to pod in another content cluster. So for that, a CNI based load balancing can be used. So more in detail, Tamil will explain.
Yeah, thanks, Mitesh, for setting the context. We had a requirement in our infra, like we need to go for a multi-cluster for one of our microservice. So we thought we already have a Linkerd for our few use cases like progressive delivery and network encryption. We just thought of enabling a multi-cluster on the service mesh level as well. So, but that doesn't goes good because we found that when we enabled multi-clustering at service mesh level, have incurred a lot of costs on that. So it requires us to, for our particular use case, we need to find out what are the other possibilities, and we found there is no tailor fit product when it comes to multi-cluster load balancing. So this needs to be carried out case by case. So we will share what I have learned in those journey. The first one is what, as Mitesh told, is GSLB, which is called Global Server Load Balancing, which is a common term which is used in industry where you want to load balance an application which spread across multiple regions, or in case of Kubernetes, if it's spread across multiple clusters. And as Mitesh told, it is DNS-based load balancing. There are few products. I mean, there are a lot of matured vendor products are available, and also a lot of open source products are available in this space. But I have particularly chosen a product which is a CNCF-based open source project, which is called KAGB. It has, I felt it has a lot of advantages compared to the other vendors or projects in this space. I will discuss in the next slide. Just before that, I mean, typically, let's say you have an application which is called example.com, and you want to expose to an external world. You'll just create an ingress object, and you have it points to, I mean, basically the client connects to the DNS, and it will be route to the cluster. And if it's, let's say you have a multiple cluster and your use case is very simple, so you can replicate the same application across the cluster, and it will, your DNS entries will be updated. So when the client connects to the domain name, it will route across the clusters. Okay. So we'll see how this architecture look like, how this KGB project will look like when you install a KGB in your cluster. It uses subset of other Kubernetes open source projects like Core DNS. So basically, the Core DNS with KGB controller maintains is kind of a zone delegation. So when you have an HDNS server, it will be configured as a zone delegation. Basically, you won't be creating a DNS on your Route 53 sort of Route 53 or HDNS. So you will give an authoritative name server as this core DNS, which is running in this KGB namespace, and it has something called other open source project which is called external DNS. So it helps you to configure your upstream DNS. Let's say you have your if you have your infra is in AWS or GCP or on-prem, so it has support for all the upstream DNS configurations actually. And it uses one more DNS endpoint CRD. So let's say you already have an ingress object, or you can use an annotation, or what you can do is like you can use a GSLB CRD. So once you create a GSLB CRD, it will create an ingress object like what we have seen in the other slide. Once you have this ingress created, so if based on the application health, and the ingress always have an public facing IP, right? So this KGB controller will get those details and update the DNS endpoint CRD basically. And then once the DNS endpoint CRD is updated, there is a core DNS instance running. In core DNS, you can always add a plugin. So in KGB, they are adding a plugin to watch for this DNS endpoint CRD and updating the core DNS entry, which is running within this cluster. So from within a cluster, when you create a GSLB CRD, it can able to detect and create a CNAME in your the local core DNS instance. We'll see how this works when you have multiple clusters.
Yeah, if you have any question in between, you can ask us. No.
No, this is not specific to CNI actually.
That is CNI based solution. CNI based in third strategy.
Okay, so when you use a KGB based or a DNS based load balancing, the advantage is like it is a CNI agnostic. So whatever CNI if you are already using, you can still work with it. So currently we are using Cilium, and then we are using VPC CNI as well. Like, so for few clusters we are using VPC CNI from AWS, and yeah, built-in CNI. And few cases we need functionalities like network policies were not there, and the pod startup time was not good when at scale. So we have moved to Cilium in those cases. So we have a few set of clusters For data pipeline, we have a separate cluster, and general purpose, we have separate cluster. So the CNI is selected based on that.
Hello. Hello.
Yes. Service mesh, we are using Linkerd in our because we specifically need it for a network encryption. So we felt it was best choice for us compared to when we.
Let us leave it to.
Might be we'll take that later actually. So. Uh, Maybe we'll talk offline later or
That
discuss
third
with you.
point is about that CNI based.
In case of K8GB, right? How do pods of the same service communicate?
Parts of the same service. So that confined within the cluster, right? Like you have a kube proxy, which will, let's say you have a service within the cluster that you have a cluster IP that goes to the kube proxy and that routes to the pod.
I think
That is in.
next slide.
Okay. Sure, yeah. So this is a CRD object I have told about, like you need to create this GSLB or CRD object, which is across the cluster for a multi-cluster, if you want to route across cluster using GSLB. And it has multiple strategies. So by default is round robin. It has traffic split, failover, primary, secondary, and you can also have geotag basically if you want based on the client location. If you have a IP reputation and DB set, you can able to route based on the client, how the client based on the client IP where the traffic comes from. We can route to the nearest cluster as such. So this is the typical end-to-end architecture, like how when you have a KSGB installed across multiple clusters. So as I told in the first slide, we can get to know if you have a single cluster, I mean, the KGB controller can read your ingress object and updates your core DNS entry. And since we have configured uh, the edge DNS server, in the edge DNS server is just zone delegated to the core DNS which is running in your cluster. So basically, this core DNS service should be publicly, it should be of service of type load balancer, and it should be faceable at the client facing network. So that's one thing required. So you might be thinking how it is doing the multi-cluster service discovery. So this, I mean, if you see any other vendor products or other tools, right, they will be having a dedicated control plane, or what they'll be doing is like they'll be talking to your Kubernetes API server, which is present on the other clusters. But if you see KGB, this is what I like more about this product is like it uses the DNS itself to do the state transfer. So how it does is like when you register your core DNS, which is running in KGB, to your HDNS server, right? Similarly, other clusters also register to the same HDNS server. So KGB controller, what it does, it will always polls the HDNS and try to get the other name servers, which is a record it is able to get the other name servers, which is comes from other clusters. So once it has the other name servers, it also has the tags, which region it comes from and what particular cluster you have. Those tags will be added in the CNAMEs. So then what it does is like it do a recursive reconciliation. From the cluster one, what it does is like in DNS, there is a protocol called XFR. It will try to get the zone records from other cluster. So from that, it can able to update the endpoints in the particular zone. Similarly, the other cluster can able to get it from the other name server details. Basically, there is no dedicated control plan as such, and everything works on the DNS protocol. So it is very lightweight, and if your use case is only for a DR or multi-cluster load balancing, of cluster grows in other cases like service mesh or CNI, right? You need to pull the API server in other cluster, not required in this particular use case, everything works on top of a DNS protocol. It is able to do the load balancing. So it is ideal for client-facing applications where for north-south traffic, if you have an application which is exposed to the external world, this sort of approach is pretty simple and stable. And as we discussed, it has other routing policies like geo-tag based uh, and also traffic split. And it doesn't add any additional hop. If you see the traffic hits your HDNS and it is delegated to the zone DNS, any one of the core DNS, and then it reaches the exact cluster. So there is no additional hop, and so there is no much latency. And the one caveat I can say is like it doesn't have a very future rich what you have in service mesh or CN. I think you don't have you have a traffic splitting, but you don't have a circuit breakers or retries, progressive delivery. Few things are missing, but that's one thing. And then since this is based on DNS, right? So the DNS multiple places. So if you are at the client, if you have a multiple upstream DNS, then there will be a cache, DNS cache to whenever there is a service goes for a downtime. So you need to properly configure over a TTL in your DNS. So that's what I have observed.
Yeah, I would like to add one point that DNS TTL is due to this DNS, it is both pro and con. When we have DNS cached, so it doesn't hit the DNS, so it directly goes to the service. So that hop is not there. So it is faster. But TTL expiry is also a problem when there is some thing goes down. So it won't be reachable till that TTL expires.
And in this case, this works independently each cluster. So there is no cross cluster communication is also there, not there. And also within your environment, there is no class cluster traffic as well. So there is no AZ to AZ or VPC to VPC traffic, but it all happens at the client end. So the client will directly go to the particular cluster. So there is no AZ transfer or zone cross regional data transfer as such. Yeah. Yes. It is possible, but I think in this product, it is not yet available actually. But any DNS based or GSLB based on the request latency, you can able to route to the nearest cluster. But I think this is might be in their. I mean, it is a community project, right? If we require, we can patch or we can request for this feature set.
The only one thing is that it will work only in flat networks, right? It will not work with isolated networks. Like for example, if I have.
It will work for the isolated network. Basically, it is based on the DNS, right? Let's say you have a cluster which is spread across a different region altogether. Let's say you don't talk about multi-cluster. Let's say you have a single cluster with that isolated network. How do you expose the service? You have a IP which is reachable to the client, correct? Similarly, the same. The thing is like you have a core DNS which is needs to be reachable. I mean, there is a core DNS instance which is running across the cluster should be reachable. And then from your client, that load balancer IP, that ingress IP should be reachable.
So that means the communication is not pod to pod across multi-cluster. It is through the service network itself.
Correct, yes.
So that's the thing. So you cannot do pod to pod
Yes.
unless you're on a flat. But does it work on flat network also is my question. Okay.
It works on flat network, but this is not for a pod to pod communication. I mean, this it is not for a pod to pod.
It will not work.
Yes. This is mainly for external facing application where the client facing application where you want a high availability and you want to route it to the nearest cluster sort of thing.
You're saying I can't use it if I have to do pod to pod communication across multiple clusters.
Pod to pod, yeah, you can't use with DNS based solution as such.
Okay.
But if it's a flat network, obviously it will work because you can have the reachability. You don't need of any solutions.
That's what I'm asking. If I have a flat network and if I have a multi-cluster, if I use this K8 is G, right?
Okay.
I should be able to do it, right? Because it's a sync between coordinates, right? All the, I mean,
Yes, I think in that case, the core DNS which KGB managed doesn't comes into picture. You can use your existing core DNS and
it is across multiple. So look, there's a different coordinates in each of the clusters, right?
then, I mean, then we need to go for a CNI based approach.
I was just, okay, fine.
Okay.
I don't want to take it further. Yeah, good, thanks.
So the other approach is service mesh based multi-cluster load balancing. So we all know what is service mesh. Basically, it is for a service discovery, and it has other functionalities like a circuit breaker, network encryption, and progressive delivery of applications. Uh, so we can also, since if you see this problem of multi-cluster load balancing, you can do this at multiple levels. As we discussed, we can do at the DNS level. You can do at the application or at the sidecar proxy level, or you can do at your network level. So this approach is how they are solving is like, since the service mesh has a service to service discovery within the cluster, they're extending that to across the cluster. So basically, you will be having a cluster mesh which have a service discovery which spans across the cluster, so that it have a visibility of your services which is running on multiple clusters. So when a traffic comes, let's say a service A want to talk to service B, which is spread across different cluster, your service mesh control plane can get to know this is from a different cluster. It will update the endpoints accordingly, so that since the traffic is routed through your sidecar, basically whether it's a Linkerd or Istio NY proxy or a Linkerd proxy. So the proxy has an intelligence like how to route this traffic. If it's in cluster, it will route it to this cluster within the cluster, or if the service is spread across different cluster or a different region, so it have that visibility because you are extending the service mesh across the cluster. So to do that, there are few basic requirements we have. When you have a want to use a service mesh based approach, your API servers in each cluster must be accessible to the other cluster. So, but let's say if your a cluster is in across different region, you should make sure a firewall proper configurations are set, because exposing a API server in a public is not a right approach. But within your VPC or across VPC, yeah, if you want have a cluster mesh, the requirement is like the API server in each cluster should be reachable in other cluster. That's one thing. And then you need to have a common root CA that will create an intermediate CS certificates, because when you do a service to service across cluster, that you need to create that trust. So how does the service A or service B will trust this is coming within my cluster mesh? For that, you need to have a common root CA, and then you will be creating an intermediate CA for each cluster. So when we do an MTLS or TLS across the service, it can able to validate this is a genuine service which is coming within my trusted set of applications or cluster domain. And then the other requirement is like, I mean, if it's a flat network, you no need to have any additional requirement. Let's say, as I told, like if it's across isolated network, somewhere you need to connect to that cluster, right? That in the data plane. So you need a public IP. So for that, we will be in case of service mesh, it will be using a gateway class actually. So through gateway, it is a basically a public IP or a network which is reachable from other clusters. So that is a requirement when you go for a service mesh based approach. So as we mentioned, if you have a multiple clusters, you need to have a common shared root CS certificate, and then you need to have a gateway if the cluster is spread across isolated across different region. I mean, if you take any service mesh, this is a typical architecture look like. Even if it's Istio or Linkerd, there is a small change how Linkerd works in this case. Basically, they use something called service mirroring compared to Istio, where they create a service entries across the cluster. So those are the two small difference in the way used, but what I observed is like when I have a multiple cluster keeps growing, if when I use service mesh, right, my API server is getting throttled actually. So that you need to take care. So when you have a multiple cluster, so if every cluster is a primary, so in Istio there are few configurations. So you can have a one primary and others are secondary. So the control plane will be running in one cluster. The Istio control plane will be running in another cluster. So other Istio control plane will act as a secondary, or there is something called multi-primary. So every cluster will try to get the configurations of other clusters. So that is a default sort of thing. So if you do that, I mean, it depends like you are on the scale. If you have a high scale system, then your API server, there might be a chances of getting throttled. And what I observed is like,
Question.
yeah, well,
Latency.
yeah, yeah.
Could you please repeat?
Hi. What is the latency we are talking here?
So the latency, I mean, it depends on your use case. So whatever latency we looking for is like sub millisecond. So we can able to achieve. I mean, it should not be a issue.
Here it will be faster than GSLB based because yeah.
I mean, GSLB, the TTL is the one issue. If there is no churn in your network, TTL should be, I mean, DNS should be the best approach for an external facing. But if you have a lot of churn in your network that keeps on updating your service, then yeah, there is a TTL comes into picture. And the service mesh based approach is mainly for traffic communication, which is within your cluster. If you want to scale horizontally, this is what I mean you should do. To answer your question on the latency, it depends on your application requirement. You should have observability of once you have a multi-cluster, I mean cross-cluster communication, you should benchmark your latency. I mean, when you talk, when you work within your cluster, service to service, how is your latency, and you should see when you have a cross cluster, you should have an observability. Any service mesh will have those observability stack. You should able to measure, and if there are you found any delays or something, then we should tune your I mean networking part of that. So it might be across multiple region, or you should see where is the gap and then fix that actually.
I would like to
Mention the shared root CA thing
Ah.
and the intermediate CA. If it's not too much, can you just explain that a bit, especially in the context of something like Let's Encrypt?
Okay.
How feasible it is, and what happens if you have to own your own CAs and all that stuff? I mean, I'm just trying to, if it's not too much, too long, or too much off the.
That's fine. I mean, I'll just simply answer. These are the self-signed certificates, basically, and it can be a get it from a trusted CA as well. Basically, let's say you have an organization, you have a root domain. Let's say in case of mine, which is star.rccm.com. Let's say if I'm getting from ACM from Amazon, I can still use the same root CA to create my intermediate certificates. The reason is like the root CA will sign the intermediate CA certificates, so that whenever your proxy, that Istio proxy or on my proxy communicate across cluster, it can able to validate. I mean, if it's come from the same root CA, that's how the TLS works actually.
and
But it can be, you can use a Let's Encrypt to create the certificates, or you can use a self-signed certificate, or yeah.
Certificate has a cost associated with it normally, other than Let's Encrypt.
Okay.
So, right. So if I buy one certificate and I have to actually get the intermediate ones, I again have to buy the intermediate certificates. No. Or is it possible for me to?
Actually, these are within
wildcard,
the.
you better buy wildcard certificate.
Okay, I can buy a wildcard certificate, and then each cluster I can use that.
Yeah.
Okay. So actually, what I would suggest is, right, if this communication is within your data plane, cluster to cluster, you can use a self-signed certificate. But if you are talking to an external world, yeah, then you should obviously use a certificate from that, and then you have a subdomain, right? You will be getting a star.example.com, correct? So anyway, you have that certificate, then you will be creating an intermediate certificate. I mean, if you still want to use that, you can create an intermediate certificate signing that actually.
Usually, right, all these are credited over private links.
Yeah.
And you can have
Yeah, self sign.
connecting to your own thing, a lot of times because it gives you the Outlook certificate, many times the browsers say, no, no, aap galat se connect kar rahe ho and all that stuff, which basically creates unnecessary panic. But
So, yeah, right. So this is basically communication between the containers which are in one cluster to another cluster in Kubernetes. So for them, it's just encrypting the traffic between pod to pod. So wo wala, what you're saying, na, that will not come. That will come only front end.
And to add to the previous question, like it is a best practice, like least communicating services should be on different cluster and more communicating services should be on same cluster. That we have to do better.
Yeah. So you're building, you told sub-millisecond latencies, and I'm seeing all the clusters. I would like to understand how is your machine sizing going on to achieve sub-millisecond latencies? Machine size or VM size, cluster sizing.
So like 5 Gbps network
So
generally we use.
are you referring to a question sub-millisecond?
Yeah.
So 2 milli, okay. So that was very broad. You want to take?
Might we will take offline because I just need to give some context to get that.
Take it off.
We'll take it offline. Just, yeah. Yeah, this is how the traffic flow look like when you have a, a across cluster. Let's say, as we discussed, you have a Istio control plane that can talk to the Kubernetes API server, which is across the cluster. And then when you have a traffic from your service A, if you want to communicate within the cluster, you have a, let's say, application called foo. Your domain name will be foo.namespace svc.cluster local, correct? But what Istio does is like when it have a service which is across cluster, they create something called ns.global CNAME record actually basically. So whenever you want to try to connect to the service using that record, the sidecar will know this is not within the cluster. It should go to the Istio gateway present on the other cluster. So it will do that. It will know this endpoint is Istio gateway endpoint. And in the Istio gateway endpoint, we have a wildcard certificate. Basically, it can able to pass through it has a CNI header, so it can pass through all the domains with that particular cluster or dots global sort of thing. Then it goes to the particular service which is running on the other cluster. From there, that Istio proxy can able to validate this TLS request, MTLS. Basically, since we have the shared root CA, so this certificate, it can able to validate the whatever certificate this service A which communicate to the cluster to. So this is ideally very useful for your east-west traffic handling. So if you have a application which is spread across clusters in east-west fashion, yes, the service mesh-based approach will be a good one, and it has other functionalities like traffic splitting. And if you have let's say you have a production cluster and you have a few other, UIT kind of cluster, you want to, let's say you have deployed a new application, you want to give a 10% of the traffic to this service to test it, then you can progressively do a traffic splitting across the cluster, across service as well, or within the same service spread across different clusters. And when you go for a service mesh based approach, there is a vendor lock-in, like you need to use a particular service mesh, that's those CRDs. So if you want to migrate across a different one, so it will be a bit challenge, like you should take care of it. And when number of cluster increases, there is an overhead of inter-cluster communication, and there is limitations when you have at scale. And there is an overhead since the traffic goes through, it's a public facing one, so that overhead in your traffic. So you should benchmark those and tune those your applications accordingly. So the last one we want to discuss is a CNI based multi-cluster load balancing. So we all know CNI, which is a container network interface. Basically, when you create a pod or container, CNI is the one which gives you the network interface and the IPAM, the IP address allocation for your container. Since the CNI has those, since it's the one which creates the network on the interface and the IP address, you can leverage your CNI across clusters to have the service discovery and part-to-part communication. So for this case, we have taken Cilium because Cilium has all the feature sets to provide the multi-cluster networking. There are few requirements when you go for a CNI based multi-cluster. So you should have the worker node across cluster should be unique. I mean, the worker node IP should not collide, and the worker node should be connect each other. I mean, should be reachable. So it should be on flat network, or you should have some VPC pairing so that all node should be reachable in your network. The basically what we are doing is like if you know Cilium, it will be creating an VXLAN overlay on top of your worker node IP, right? So basically it's a overlay IP, right? So for that to function, the primary requirement is like you need to have your worker nodes reachable across cluster. But if your worker nodes are in isolated regions, then you should have a VPC pairing or connectivity so that this you can VXLAN can work on top of it. And then you should assign a pod CIDR for each cluster should be unique. So pod CIDR should not collide.
Yeah, I had a small question. When you say flat network, what do you mean?
The flat network, I mean, is like the IP is reachable. I mean, either
So an overlay network or a same L2
same
basically.
L2,
Okay.
or if it is not a flat network, you should have a peering across the network so that it looks like a flat network from a CNI point of view. CNI doesn't aware is it across cluster or something. So it for us it looks like all the nodes are in the same L2. So we should, I mean, based on your environment, we should make sure that is available. That is a primary requirement. And the one difference between the service mesh based approach and CNI based approach in the service discovery is right. Cilium uses, I mean, it doesn't requires you to expose your cluster APIs across clusters. Instead, what it does, right? The Cilium operator runs within the cluster, right? It will watch for the service objects or the whatever ingress objects and put those data in your local XCD KV store basically. So for this to work, you need to have an additional KV store. That will be a few set of pods in your each cluster. So for a class cluster communication, this XCD should be, the XCD service should be reachable from other cluster. So from there it can able to read the service of other clusters. Then it can updates the endpoint object. When you create a service object, right, you have an endpoint. So what Cilium does is like, let's say you want to global networking true, it updates the endpoints present in the other cluster to the endpoints in this cluster. Similarly, across cluster it will update. With Cilium, since the part-to-part connectivity is available, with this, I mean, let's say you connect to the service object, it lists all the endpoints across the cluster, it is routable. I mean, because the part-to-part connectivity is available. That's how the Cilium based approach look like. So, I mean, the advantage is like if you want to have a direct pod-to-pod connectivity, I mean, this might be the right approach. And you can have a hybrid approach as well. Basically, if you have a service mesh based, you can combine this with a service mesh based approach as well. Basically, you have a CNI for pod-to-pod connectivity and service mesh for a class cluster traffic management. This is also one of the approach people took. And with CNI based approach, the overhead is like it is locked to the particular CNI provider. You can't work on an existing cluster asset, so you need to plan from scratch. Or and also there is an extra overhead because when you do an VPC pairing, right, there are a lot of limitations. So you have an MTU limitation comes into picture. When you do a VPC pairing, your MTU size is set to 1500. That's limitation is there. And if this VPC is spread across different region, then egress traffic cost is also comes into picture. So you should, I mean, get those, plan those details. So the TLDR or what the optimal way is like, I mean, there is no tailor fit solution. So you should just ask this question to you. So why you are going for a multi-cluster load balancing? Is it, since, I mean, let's say if you have a linker D, you should not directly use linker your multi-cluster load balancing. First, you should define your use case. So basically, if your use case is whether is it only for high availability and disaster, And you should check whether the application is completely a stateless application or it's a stateful application. And if it's a stateless, how the DB or data is synced across clusters. That is also a cross-cluster communication you should manage. And then there are some scenarios there will be a sticky session or session persistence is also available. So you need to plan. I mean, how does this solution work when I have a sticky sessions? And if it's is it for a north south or is it for a service to service communication? Also, you should check whether it's at internal facing or it's external facing application also. And if you see service mesh is good for L7 based protocol like HTTP or gRPC, but let's say you have a service which is a custom protocol, which is a TCP or UDP, you should check whether they have those compatibility available. And then you should choose your load balancing approach. And if there are requirements, if really a pod-to-pod communication is required for your use case, then you should see which is a solution that provides pod-to-pod connectivity, and then you should go for this approach. So yeah, this is what I have experimented, and for us, it is more of a high availability and disaster use case, and few cases we need a service to service. So we have tried with the GSLB based approach as well as along with the service mesh based approach for selective set of service. So the TLDR is like of the story is like if you have a application for external traffic and across cluster and doesn't have a stateful application, you go for a DNS based DNS based GSLB because it can just work on your existing cluster as it is. And is it for scaling your service across cluster? Go for a service mesh based approach. And is it for a CNI based or pod to pod connectivity is what you are looking for? You can go with a CNI based approach. So that's all I wanted to present here. So if you have any questions, we can take or we can take it off.
I just have one question, Al. So the Cilium which you showed me, right? The CNI based.
Yes.
The latest one uses eBPF.
Yes.
Are you referring to the same one?
Yes. Yes.
Right. Okay. And I think I asked the question about the DNS ones, right? The
GSLB. GSLB.
Yeah, that one. Service mesh, which is the example you have taken?
So I have taken Istio here, but yeah, it should be applicable. I mean, same architecture. The requirements are same for Istio and Linkerd.
Okay. So which is your favorite?
No, mine. I mean, that's what I'm saying. Like for me, it's all depends on use case. For me, this is a fintech product, so they want for when we have a DR, they mainly want for a DR use case. So I first went with Linkerd because they are already using Linkerd. I said we'll go for Linkerd. Then when I start, see, I get to know it unnecessarily. I'm doing a crazy traffic because my clusters are a different region. So when I put Linkerd for my multi-cluster, I mean the latency is also increased and also it had additional costs which I need to answer. So why there is cross AZ traffic? So we don't want to have our traffic spread across AZ. So we want to have first of all our traffic within the AZ itself. So only if it's a downtime, it should go to other AZ or other region. That is our requirement. So we went with a GSLB based approach, but for few use cases we are trying out a service mesh based approach as well because we want to scale the service because it doesn't confine within one cluster.
I have been following
Istio, like if you are already using Istio, then you can go ahead with Istio.
Yes, I have a problem with these service meshes actually, right?
Okay.
So Cilium, I've been following Cilium. I think Cilium is still in beta.
Yes.
Right? They're still in beta. You're using in production today?
No, Cilium we are not using.
Not using yet. So how many of them use Kubernetes with service mesh here? Raise of hands. How many Kubernetes with service meshes? So you see, the only reason, I'll just put one point there. The only reason I like Cilium is, that's a future. I think if they come up, it will be big. If you use any of these service meshes like Istio or Linkerd, your packet actually flows all the way through 7 layers, come down, again go back. It's like, it's like a wave. Whereas if you use eBPF, that is Cilium, which they're still in beta. And if you use that, you are like, it's just one way. Like you just hit to the, if you just go 2 layers, that's it. Not full 7 layers. It's not like a wave. You go 7 layers up, come down, again go 7 layers to the container, take the request back, again go to the service mesh container, again go out. So that is eliminated in that Cilium. So I was interested if he was trying in.
So Cilium has been eBPF based through the very beginning, I guess.
Yes.
So it's not only in beta, it's been in production since the very beginning.
Is the multi-cluster?
Yeah, the multi-cluster.
That service discovery across cluster for,
Yeah.
I mean, EBA based thing is
Yeah. So
in beta.
I was curious if you're using in production, that's why. Which one? Sorry.
So
There is something called ambient mist, which is coming out. It's again.
it's in Istio, there is something
So
called,
it
instead
also
of,
uses EBF, right?
basically instead of having a sidecar, they're having that data plane, the proxy layer will run in the node as a daemon that use eBPF to, that is, in Istio, there is now the feature, but it is all
even
on
if
beta.
it does go through all those layers, right? Amount of latency it adds is generally in milliseconds. Unless you are optimizing for every millisecond, it doesn't really matter.
No, I'll tell you what, because if you have a mid-scale, it should not be a problem. Ours is pretty large cluster, very large. We fight for 1 millisecond there. And in that, it matters a little bit. That's why I was asking if we can go for, if it's in production, I thought of trying it out. Yeah, any other questions, guys?
Last question.
Yeah, this is not a Gen AI sort of topic, but hope this is not boring as well, so.
Yeah, I think. Let's take a question. Lunch, and I'll be keeping you between lunch and stuff for another 15 minutes probably. Thanks to Mitesh and Amit.
Thanks for the opportunity.
Come in, yeah, sorry. Yeah. Please. It was actually a great talk. I'm seeing a lot of questions, so that's why you understand with the quality of talk here. Thank you. Hello. 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 Okay, so you're good. Okay, so hello everyone. So bear with me. I won't take more than 10 minutes probably. Why this is important? Because we talked about much about it. 50th event, 11 years. And in between, there are some folks who were bringing us, me specifically on the meetup group, that how do you organize meetups? So I have created few slides. I'm pretty much sorry that it is all black and white. There's no color, no picture in it, all text. So bear with me. And all the organizers, Anshu, you have to be on camera. Just post this because we need you guys. I'll be calling you on stage, and Anil is there. Will be helping us to celebrate ourselves. Okay, so 11 years of lspe-in. What is the story around? Probably some organizers up here who will take some lessons from this thing. So when we started in 2012, this was a story where web operations were getting streamlined. Like there are less signs, more art there. And I was discussing this with Ashutosh in the morning that most probably this is not true. But we'll come to that debate later. But this was the starting point where there's a book called Web Operations. You see, this is coming out of the Velocity Conference talks and write-ups. And there's the preface of the book says, which is like G.C. Robbins written, web operation is an art, not a science, for a reason. For a reason, that's most important. Okay, there are no standards, certifications. I mean, you still go at a DevOps certification, right? Nobody does it. You can get a RHL certification, but there is no DevOps or SRE certification. So those things we don't get. I don't know, we is calling me. I'm sorry. And everyone, it takes a long time to learn and longer to master. You can still learn, but you all know how to. Do you still remember how to read SAR command output? Anyone here? Okay, there are a few hands raised. Thanks for that. I'm pretty much sure Nishan didn't raise hand. Okay, so this takes a lot of time to master. Okay, and this is still true. We defined ourselves. We have given a character to us. We said that we are large-scale production engineers. What it means scale today, what scale meant that those days are different though. But we still say that we are the large-scale production engineers. We are the offspring of internet age. I mean, people may like it, may not like it, but that's what it is. Okay, and we're the first to know when the fiber is cut by a squirrel or something of that sort, right? If even a shark cuts under the sea, we'll know that that network spike will come to know first. Okay, and every case is man machine whether everything challenged us, and we tried to defend that. And cloud containers, Jira, Slack, all changed our life. And now, obviously, GenAI has changed our life too. Okay, I haven't added this slide. Excuse me for my laziness, but I have lazier people here sitting around behind the rows. Okay, so and our civilized names keep on changing. It's an interesting thing, right? When we started, we were production engineers. Then somebody said we are DevOps. Then somebody said we are SREs. Now we are saying that, okay, we are cloud operation engineers. Tomorrow there will be platform engineers, AI engineers. So civilization has changed our names, but end of the day, we are probably doing the same thing. Okay, the community journey till now. We started in 9th June 2012. Now, probably people will ask me, your mathematics is not adding up. I'll explain why. Our meetup today, I mean, I just saw in meetup, we are roughly around 3,600 people. Okay, not a big number. I'm pretty much sure the DevOps group had very large number. Unfortunately, that group died. I haven't seen they are organizing any meetup in last 5 years. Okay. So we did not miss a single event till now. COVID had a challenge the first quarter of the COVID, but then Anshu sitting in the back end solved this. We went online during COVID, and those of you who are trying to build a meetup, run a meetup, consistency pays. We are live because we are consistent. We never missed. Okay, छोड़ दो ये quarter, अगले quarter देख लेंगे. We haven't done it. it was difficult to get speakers at different point, but we continued. We never left one single event, and all the organizers knows what is the drama back end goes on when we start plan for the next event. Okay, 3,000 plus odd participants. It could be more than that actually over this 50 events till now. We don't give statistics. Then people say you are not data centric. That's not the right thing. So I'm giving some statistics. 140 plus talks shared by all of you, the community folks. The lazy ones are sitting there, haven't even spoken. That's a different story. Okay, journey till now continues. We could get support from speakers from 46 companies, and that's what is important. Be in your company, spread this. That we need to share. We need to share and bring up with your talks. Okay. From one sponsor, when we started, it was only Yahoo. We have like more sponsor now. 4 is not the right number. We have Yahoo supporting us. We had LinkedIn, Walmart Labs, Grab, Crate, and Mintra. This is our second event in Mintra, and we are actually fortunate, thanks to all the companies, management, and leadership, that they continue to supporting us. Otherwise, would have been no existence for us. We have seen encouraging feedback, which has kept us moving. I mean, discouraging ones as well, but then you have to take it with a balance. Okay, at times you get a meetup where 30 people turn up. Obviously, that's pretty frustrating. 60 plus 60 to 70 being our general numbers. LinkedIn has some magic. Whenever we go to LinkedIn, it crosses 100 plus. So don't know how it works. Ashutosh will beat it. He will prove it wrong. Okay. Collaboration, I'm quoting this. This is not my word. I read a journal continuously every month. This is called the Communications of the Association of Computing Machinery. There, Andrew Chen was one of the editors. He wrote, "Collaboration in computing research enters an age of distrust." We are really not. And if you have seen the large language models, how they're being developed and spread, I think there is no point of disagreement here. Computer science faces a dilemma. I mean, physicists had dilemma recently, this new film, which was that on the atom bomb, the American Prometheus, Oppenheimer, you have seen that movie. So, and the movie is full of that dilemma what physicists faced during 1942s and stuff. Okay, the dilemma biologists faced when human genome cloning and human genome project was at its peak, right? So most probably I mean, I don't claim to be a computer scientist. Obviously, there are people who do a lot of computing research. Overall, computing community probably is under the dilemma with AI. Somebody created some model which marked someone as Nazi, and it was not accepted well, right? So a lot of challenges up there. Cybersecurity, privacy, and now AI is the dilemma where we are at the fence. Lot of collaboration. IRC is dead. Okay, in my own company, there is still an IRC server, but I don't see anybody there. If you go to Freenode, okay, where there's a lot of the open source channels resides, even in Debian, I see 4 persons at some time, which is very, very crazy. Means people are out of IRC now, everybody is Slack, and there's no way you can have Slack in like an open medium. Okay. So all are closed source collaboration tools now. Then many Floss gigs today stopped working on free software. I still carry a Debian laptop, and all my computing environments at home are all free software. But then due to different things, I mean, office restrictions and stuff and all those stuff. There's something on phone which is Android, seems to be a free software, but all the drivers are actually proprietary, so we don't get a free stack. And then we stopped assembling our own devices. How many of you assembled a computer in the last 3 years? Raise your hand. 2, 3. See, not even 10%. Not even 10% if I include myself. on the assembling gigs. So lost. So Roland was in Flipkart at some point in time. They had a business called Flight. It was like high quality MP3 music. Didn't fly off because right? We copy and share. So they didn't have. But then they were the first large scale implementation of Gluster FS. Who remembers that? Nobody probably. Okay, so we are not modeling our values. We are spreading wrong sense, and that's a concerning thing. Concerning thing in the community. Humanity doesn't survive in that way. We have allowed foundational changes in HTTP and HTML. You see, lot of the space is no more free software. All these things are like React and stuff. The templates and all, everything is kind of like half open, half source, half open, half closed kind of a scenario. And we are forgetting GPL matters. If you look at cloud companies, the way the cloud companies are using free software, what GPL had different than Apache license? GPL had this, if you have modified the code, using it for a business, no problem. Do share it back to the community. There are few codes which is coming back to the community. It's not that 100% code modified is not coming back to the community. But then there are tons of code which is never coming back to the community for the sake of business. That's not the right sense, probably. I mean, I'm not the person to say the last thing. So we need to share our learning. That's why we need the community. We need to share our challenges. We need to know who are our experts. Okay, when I go to Roland, when I go to Anil, when I go to Mitesh, do we have their handle? Can we offline ping them? So that's what the community means, right? That's the platform we tried to build for 11 years now. Okay, and obviously when we started, there was nothing like it, nothing similar to LSP in India. So we created it. We survived for 11 years. Now we need a lot of you. Then Yahoo backed us. Now Yahoo is not in a position to back us anymore. So that's why we are going in many places now. The community is more important now. As I said, the values which Andrew Chen talked about, the different trends that we just discussed, the community is more important right now. Okay. So from now, we are looking for more participation from all of you. That's how lspe-in survived and will continue to survive. Without you, there is nothing called lspe-in. Oh, there is no buzz. Nobody runs it. No business supports it. Runs it behind with any interest. It's only the community. Okay, so more sponsors is the need of the hour. We got Myntra, we got Grab, we got Cred. All of them are supporting us now. These are all Indian companies, and that's the most important part. We have got our ecosystem, but at times they have their ups and downs. So we need more of you here. But we need to bridge academia and industry. So this is one place where we lost. We lost like we are unable to get speakers from academia. So if you get to those persons, I mean, many of the companies actually stopped any research link now. They have their own research, but not really related, associated with the academia, like ISC and IITs and stuff. So if you have link, if you have your company, so bring those folks to LSP, propose them as speakers. We are open there. There were at times, like every LSP event, we had speaker from IIT, one speaker from ISC, something of that sort we did in early 3-4 years. We lost that for very long now. Join us. These are the handles. With this, we'll stop, and I'll request all the organizers, Anil, Srini, Ashutosh, Varada, Nishant, whoever is there, please come on stage. Sharmila, please come on stage who worked for the LSP. No, it's all right. So don't use it. It's dead. Yeah. We have a Google group. There is a Slack channel. It is still there. It is still there, but very. I will do. Forgive me. I didn't change the slide. We'll share that. We'll share that. Yeah, please be on stage. Varada, Srini, Sharmila. Sai, would you do a grace to take some photos of this gang? Anshu, can you come on camera, please? Anshu? Yeah. Just. Yep, Anshu is there. Okay, let's get Anshu's face visible. You're blocking Anshu.
Good to see.
Yeah.
Yes, everyone much
For the
better for
side.
the time being. Yes, hope to be.
Anshu, you are on mute if you are speaking.
No, definitely. Thanks, Avanshu. Good to hear about everything, and definitely looking forward to a lot more participation from the community. Like what you were sharing is earlier in the intro, a lot of first timers. So yes, looking forward to have more of them getting LSP into their companies and pieces. So yes.
Thanks everyone. So we have some LSP goodies. Most probably Anil we will distribute that later and with the speakers as well. So with this we break for lunch. Okay, and if you have any questions to the organizers, please feel free to shoot.
Brown plate for veg, light brown plate for non-veg.
Okay, so they have a protocol. When you pick up a plate on the cafeteria, brown plate is for the veggies. Yeah, dark brown is for veg, light brown is for non-veg. So if you take the wrong plate, you will be served different things. That's okay. Yeah. Okay, any further questions, please? Otherwise, we are available there. Fine. Thank you very much.
Oh, yeah. Okay, yeah, but like we need to review the slides.
Hey.
I have to say so. I feel that see, I mean, I heard a lot more. Like we have become like less collaborative over the years. As a
Yeah.
it's a very distributed serverless platform. So we sent to
चिढ़ाते हो आप आपको भी पता है वो चीज कि आपको पता है मैं इस बात से चिढ़ूंगी तो आप वही करोगे जी नहीं क्यों चिढ़ते हो हम आप जो करते हो क्यों आपको क्या है क्यों चिढ़ाते हो नहीं क्यों तो इसलिए नहीं लगाई है मैंने लगा लो कभी इसलिए अब ऐसे शौक है तो नहीं है तो मैं क्या करूँ तो शौक ये तो नहीं बोल रहे कि शौक है शौक कर लो मतलब मेरे लिए कर लो मजे लेने के लिए ये तो नहीं बोलते कि 24 घंटे लगा के बैठे रहो लेकिन क्या कोई मजे देने का सामान नहीं है हाँ तो वो तो पता है तुम ये क्यों बोल रहे मजे देने का सामान है जाओ सो लो हाँ तो सुनी जा रहा है बम कमिंग क्या क्या बोले बम कमिंग Hey folks, not sure if people are talking in the room. I can't hear anything.
is part of my team. Myself, Sanjeev. Uh, so in this whole initiative, I think most of the actual implementation was done by Anshuman. I was more of a guide. And this was one initiative where we shifted all of our components from one region to another. And for other components, we had a lot of experience. And let's say we have a database team that was owning those databases. HBase was owned by applications team. So this was done first time by us. So there were a lot of unknowns and how we did it. We just wanted to share the learnings. So what was the problem statement? Problem statement was very simple. Identify all the HBase clusters that were used inside Myntra and transfer those clusters from this region to another region without losing data, or let's say very minimal data if the data is not very critical, and make sure the data is right on the target region. Okay. So the agenda would be, first we'll talk, I have given an overview of problem statement, then we'll give some overview of what HBase is. We'll talk about a couple of approaches that are there in HBase. We'll talk about some of the tools that we used. We'll also talk about some of the learnings that we had in this journey. So when you do a very large migration of the data for a data store, uh, at a high level, there are 3, 4 things that were the benchmark criteria for us to move the data. First was data has to be consistent. We cannot lose the data if the data is very important, correct? Second thing is resource utilization, how much resources you will use and how much time it will take to move the data. That was another consideration. And third thing is based upon the use case, what should be your tolerance of data loss? Uh, so I will very high level give a overview of HBase. So HBase is a database that was built on the learnings from the big table. Uh, so it is a distributed NoSQL data store. If you look at the diagram there, so there is a HBase master and then you have region servers. So HBase master is more of a master that takes care of all the cluster level operations. Region servers are the one that handle the actual read-write workload. And it uses SDFS at the file store. So the advantage of using SDFS is like it can, because SDFS is very powerful in streaming large chunk of the data read write. And if the data is immutable, so you get a very large throughput. Another thing with SDFS you get is it takes care of the data replication by default. So HBase team need not to worry about replication of the data consistency, correct? So that is given by default by SDFS. And in the region server, if you see, most of the work that is done by the database is to have a view of like, what is my schema, what are the tables, which tables are in which SDFL file system, how the transactions are handled, and the data is sharded. So there are multiple regions. So region is one partition in HBase. So you can assume when we say region, it is one partition, and region server can handle the workload of multiple regions. Correct. And it uses Zookeeper for coordination across the cluster. But if you look at overall, it is a column-oriented database. So you have a row key, and then you can define a list of columns and another list of columns. One list of column is a column family, correct? And it stores the column family's data together. So that's why it is called column family database. And we were using a couple of use cases. We were using HBase in analytics. One of the use case we were also using in Myntra for HBase was recommendations, aggregation of recommendation pipeline and serving some of the recommendations.
So basically, before continuing and telling like how we did it and what we did it, what were the challenges and learnings, we'll try to cover basically whatever the cluster details. So you'll get a rough idea how basically big cluster was and how difficult it was to achieve it. So basically, we had three HBase masters, which basically each have 8 cores and 32 GB RAM. Then we have a 32 HBase region servers, basically, which takes care of all the data and all. So each server was 32 cores and it contains of like 128 GB RAM. So behind this, we are using HDFS as a storage architecture. The application factor was 3 and the data was in few TBs and there was a replication factor also. Then you can multiply it by 3. Then basically from our source cluster, we moved to the target cluster. The source cluster was using SDT as a disk, but in the target cluster, we use SDT because we had seen a lot of improvements during the POC and all. So, we'll talk about the approaches now. So basically, when we did some research and we figured out like there were majorly 3 approaches which we can use to migrate the data without any issues. So we'll talk one by one. One of the approach was the full backup and restore strategy. In this strategy, what we will do, basically we'll take a snapshot of the data and migrate to the target cluster and restore it. So it will have some downtime because we are not taking care of the delta data, right? Then to reduce the downtime, the second approach comes, which is the gradual migration, basically in which we will do migration of the data. Then again, we will do delta data. Then we will keep going till we can have the basically minimize the downtime. Then the third approach comes the HBase replicate strategy. So this strategy comes into the picture when you want to do the near real-time migration without losing much data and even with a less downtime. So these are 3 approaches which we have considered. So Sanjeev will talk about the full backup and restore now.
This is the easiest approach. This can be used in some of the use cases. So we have some of the data that was aggregated in HBase, let's say every day. So there, like we can pause the job, take the snapshot, move the data all together, and then enable the job on that side. So there is no serving traffic or nobody is using that. So for those kind of use cases, you have enough time to take the snapshot, transfer the data. So this is very, very easy approach based upon the use case you can leverage is. The only con of this approach is like you need to see the data size, how much you also need to do the calculations. The another thing that we had is like because this data transfer is happening between cross region, you have very limited pipe through which the data will transfer and that pipe is very costly. So that's why you have fixed GB of fixed pipe bandwidth and that we took based upon the need. So we cannot take that because that is dedicated pipeline. You cannot increase that capacity just for this migration. So that will also increase your time. So you need to factor that in. So one of use cases we use this approach. There also we had couple of TBs of data that was more of a offline analytics of the use case. I will just go over the second approach. I think it's very clear from the diagram that you see here. There is a HBase cluster there. We take a snapshot. We use the yarn cluster, correct? So when you stream the data from snapshot to destination cluster, there is a lot of streaming of the data, correct? And you have to do parallel reads across multiple nodes. There is a disk IO that is happening. If you want to increase that speed, you need to put the yarn cluster and add more nodes on the yarn so it can read the data from multiple blocks faster and then you can increase the speed. But you cannot increase that speed more than, let's say, that pipe that you have, correct? So you need to make sure that what should be the speed of the transfer and that data goes into another SDFS cluster and then you can import the data. So the export and import commands are very, very cheap. So if you know in HBase, when the data is written, that data is immutable. Like once you write the data, even if you do a update, that is written into separate file. So this uses LSM tree kind of structure. So you just keep on writing. You generate one file. If you are doing updates, you keep on writing on another file. Now you have two versions. During read, both the versions are read and merged and served. So there is no in-place update happens during HBase. So the files are immutable. So when you take a snapshot, you don't copy the files. You just take a symlink to the file because that file is never going to change. So if you say, let's say, text snapshot, that is very, very cheap. There is no impact on, let's say, even the production is running, right? Because it just creates the symlinks and attaches the metadata in this snapshot from this timestamp. These are the files and these are the symlinks, correct? So it's very cheap. Similarly, the only time you take is when you ship those data from the yarn cluster, then the disk IO happens. And similarly, once you have moved those files there, import cluster is also very cheap. They are just symlinks, they will move into the HBase. So I think this is how the overall approach works. I will go on to the second part. So this approach is one level above the previous approach. How does it works is, let's say you take the one full snapshot first time, and then let's say that snapshot takes, let's say, a couple of hours. Then you can also take incremental snapshot because first snapshot will be very, very big. That will take a couple of hours. Then you can say, now I have the data from last six hours, take another incremental snapshot and then again move it. So that may take another 15 minutes. So maybe it is okay for your application, let's say, to take the downtime for 15 minutes, and you can manage somehow, let's say if the traffic is very low during night, you can put, let's say, some banner over there, or let's say if it is internal application, you can block that. So it is still manageable in some of the use cases. So this is very, very helpful. You first do the full snapshot and then the incremental snapshot. The process is same. The only thing is you need to automate that process because you are doing this in production, so you will not get much time, correct? So you need to automate, and incremental snapshot should flow automatically and get imported on the other side. Yeah, I will just ask Anshuman to next.
Sure. So basically downside of this approach is ki, like we have to do multiple migrations and we have to maintain the order also of all the steps. Otherwise it will lead to some inconsistency of the data. So I'll go to the third approach. Basically, it's not a full-fledged approach because it doesn't migrate the whole data from source cluster to target cluster, but it helps in the migration of the incremental data or delta data, we can say. So how does it work? So basically, in the diagram, we can see we have a region server, source region server, and the target region server. And each region server has a wall shipping agent. So I would like to talk about wall. Basically, wall is a write head log file, basically which takes care of the all the data which is going right to the, let's say we create a new row. So it will write into the wall file. So basically, in case of data recovery, we can replay that wall file to recover our data. So each database has this wall file concept. So it leverages this concept to basically migrate this all the new written data to the target cluster. And there we have a replication endpoint basically which captures this wall files and again replay this in the new cluster. So we will have almost every time in consistent data, because every time let's say you created a new row and then you update it. So the same step will be performed in the target cluster also. So it will help us to migrate the incremental data, but it won't be able to migrate whole like TBs of data. So we use this approach for the data migration. And the challenging part is this key for creating the replication and everything, we have to do a lot of configuration changes. We have to make sure that this source cluster knows that this is the peer cluster and it has to migrate the data, disabling the peer and all this thing. And other challenge was that whenever we start the replication, we have to make sure that we throttle this part. Otherwise, what can happen? Let's say start migrating the data, right? It can be a lot of writes are coming. Then it will also start replicating those write to the target cluster. And eventually memstore can have some issue while flushing the data to disk. So how the writes happen in the HBase is, let's say whenever the new write comes, it will try to write in memstore, that is in memory. Then eventually after some threshold, it will flush to the disk. If a lot of writes are coming and memstore is not able to cope up with it, then a lot of disk IO will happen and eventually it won't able to serve new writes and eventually the process will get failed. So we have to make sure we are throttling this process, otherwise it can lead to the data corruption also. So we'll come to the final approach. Basically, what we did and finally what we decided. So it was not a one approach. We chose two approaches for this. First was the full backup and restore, which Sanjeev has already talked about, and the second was the H-based replication. So full backup and restore we used for migrating the whole snapshot. So let's say we have 10 TBs of data. We migrated the whole 10 TB data with the full backup and restore, but the incremental data we used for the H-based replication to migrate this. So it will make sure we have a data consistency, and we use this approach to basically minimize the downtime of our migration. We'll come to the diagram to explain like how this exactly works. So how this works basically, our table has to be configured to make sure it can replicate the data. So if it is not configured, then we have to disable the table. This part, we have to make sure it will stops all the writes and reads. In the disabled state, it can't serve any read and write. Then we have to basically enable the table replication. After that, the main process will start. This was the pre-request for it. So we will add the peer. Peer would be still target cluster. We have to specify that this is the zookeeper, which we have to make sure that this will be consuming all the incremental data. Then we have to enable the table replication again. Then we will disable the peer. So this part might seems to be confusing, but the reason behind is let's say uh, there are two things, right? First of all, we have to export the whole data, and there is the replication part. Why we did this step first? Because we did the, let's say we started the replication, we posed it. The reason behind is as we told already, right? This replication part is basically using the whole file. If we don't post the replication, then it will keep clearing the old whole files, and we won't have the data. So before exporting the snapshot, we have to post this replication, so it won't delete the whole files. Basically, it tells the low cleaner you don't have to delete, keep it for a long time. And then we basically take a snapshot. Now the snapshot has the current data. Basically, it creates a sim links. Then we use the yarn cluster. Yarn cluster is basically a resource manager which we can use to distribute the task throughout the multiple nodes. We can do this without yarn cluster also, but it will take a lot of time. We use the yarn cluster to distribute this task, and it will start migrating all the H files and metadata to the target cluster. When this whole snapshot is done, it will migrate to some directory, whatever we have specified. Then there is a specific directory in the H base where it makes sure there is some snapshot exist in the cluster. So we have to move that snapshot to that specific directory. Then before restoring the snapshot, we have to disable the table, because it basically it's a way of HBase to making sure there are no new writes are coming, and it can easily replicate, basically import this snapshot. We disable the table, then we restore the snapshot, then we can enable the table so new writes and reads can come. After this thing, now our whole TBs of data has been migrated. But now we have to start the peer application also. So let's say this process took like 2 to 3 hours. Now because of disabling the peer, we have all the whole files which were required. Now if we enable the peer, it will start from the oldest log file and will start replicating to the target cluster, and then we'll start writing all the new data. So this is how the whole final approach works. And so basically it helps us to minimize the downtime. How does it help? Basically, when we did the export snapshot and we had the replication data also, right? We just need a few minutes of time to make sure application is now pointing to the new cluster. That's it. So mostly we need like 2 to 3 minutes of downtime for it. So we will talk about tools also. Basically, there were two approaches, right? Full backup and restore, and second was the replication strategy. So there are multiple ways of exporting the data from the source cluster to target cluster, and there were multiple ways of doing it. So we figured out there were majorly three main ways of doing it. One was the Azure utils, basically using some Azure commands to migrate the whole snapshot of the data. Second was the copy table command, where basically we can scan the one table and then do the same thing to the basically transfer the same data to the target cluster. And third was the export snapshot, which was our basically final choice, which we'll cover basically in depth also in the next slides, where we basically took the snapshot, it creates the same links, and then basically when yarn cluster starts reading all those H files and starts sending to the target cluster. So I'll ask Sanjeev to take care of the Azure utils part.
Hello. So this is the approach. So when we say Azure utils, I think we have kept Azure here because we were using Azure. So nothing related to like in other cloud, something else would be there. So other approach is, let's say if you have your pipe that is across your region that is running, and you don't have too much time and you cannot push the data through that pipe. So another approach is take the snapshot, run your yarn cluster. That yarn cluster will put your snapshot onto the blob store of some of the cloud provider. So there you can use the internet also as a cheap replication mechanism from this Azure blob to another Azure blob. So this is from that angle, I think this is this approach, like so much data and you want to minimize the cost and you have enough time. In our case, we initially evaluated it, but when we did the calculations, when we evaluated how much time we will need, we were able to do without this approach only from the previous approach that we told, directly stream the data from yarn cluster to the target cluster. But just want to give you an idea, this is why this approach was actually evaluated in the first place, just to make sure that in the interim, if that pipe is not usable, we have another fallback approach that we can stream the data from Azure blob to another destination Azure blob, and there from another yarn cluster we can stream back. So this is.
Sure. Now we'll talk about the other two approaches. So HBase provides two ways of doing it. One is the copy table. Actually, this was the only way few years back to migrate the data from one cluster to another cluster. But then there were a lot of issues with this approach. So I'll talk about issues first. So there is one of the major issues, performance issue. So why does it happen? The copy table basically scans the whole table, then transfer the data. So this scanning the reads and doing the transfer of data can create a lot of problem with the production. So if you are scanning the whole table, there will be a lot of IOs will be used, right? And it can impact our production. So this was one of the approach which SBase used, but now it doesn't recommend that. So another was key, we can't do the, basically as in the second approach we told, right? We might need to do the gradual migration of the data. It doesn't support that. And the another thing is it doesn't even support the compression, because it's going to scan the whole table. So it doesn't have the compression functionality also, which might increase our overall migration time. So, and the third, the major issue was with this approach was that it is not able to transfer the metadata. So there is one source cluster, there is a target cluster. If you create everything similar to the source cluster in the target cluster, like exactly table and everything, then it might work, but there can be some hidden meta files which we haven't migrated by our own, and that can cause some issues. So it doesn't transfer the metadata. That was the very important part which is, it was not serving, so we don't use it. Basically, copy table is used whenever you want to transfer the data. Let's say you want to create a copy of your table in the same cluster, right? So it will help a lot, but it is not meant for the large data and for migration of the data. The third approach is basically the final approach which we used is export snapshot. So this is meant for this purpose only, for migration of the large database from one cluster to another, or even the cross DC or same DC. So how does this work? We create a snapshot. The snapshot takes like 1 minute maximum or 2 minutes. Why? Because it does has to make sure ki where are the all the edge files exist, and it has to just create a reference for it. It doesn't have to copy any data, or it doesn't have to like create a duplicate data. So it's very fast process. Then after taking the snapshot, we have to migrate this snapshot from source to target. That way, basically, this is the where it comes the major part of disk IOs and all. So we can do this without any yarn cluster or anything, but that will take a lot of time because we are executing this on one node, right? So we use yarn cluster, and with the export snapshot, we were able to do like transfer TBs of data in few hours. Okay, and it helps in the compression also. We can transfer the data, like even if it's in TB data, we can compress it to like half of the data. Okay, yeah, sure. I would have gone for the same approach.
But then the snapshot would have been too large to take, right?
No, so basically when you take the snapshot, it doesn't do the copies or moving from one profile to some other place. It will just create the same links. It will have the same exact thing.
But then at that level, okay, let me change my question. If you have petabytes of data and you also have huge, let's say, multiple dozens of GBs of data coming in, which your after taking the snapshot, the amount of data which has come in after the snapshot is also very large. Would it still have worked?
It would have worked, but we have to make sure that our replication process is also able to cope up with it. If it is not able to cope up, then we might have gone with a gradual migration approach. Then eventually we could have moved to the replication one. But we didn't have that much write comings in the production. So, and gradual will makes very complex also because we have to migrate multiple steps, right? So that was the.
Okay.
So if the data size is very large, one thing you can do is you can also isolate your data migration based upon the use cases. You may not, if the data size, you will have multiple tables, or let's say, so you can take table-wise approach, let's say first non-critical, get experience, divide your data migration into phases. And let's say here, let's say if it is only one cluster, if you are migrating the data, do you want to separate out the use case and create different cluster for the time being? So I think there are different approaches based upon what use cases are there. You can divide that data and incrementally do that. Second thing is, if the data is very large, Azure also provides a facility that they can give you the disk and you can put the data into the disk. They will take it and they will move the data there. But that approach is human approach, correct? Requires time. If some of the data disk is lost, everything. But that if the data size is very large, they also recommend to use that approach. But that also requires the downtime, correct? So meanwhile, people are taking the disk backup from here. Somebody will take there and put into another data center. So that is another approach. Third approach is the data cost can be very high if the data is through the pipes. So the other thing I told you, correct? Use, let's say, over the internet data transfer, correct? Just to reduce the cost. I think these are the approaches. I think similarly here, I think we had multiple clusters. We took the different approaches where it works based upon the use cases. It was not very hard. One approach we will take everywhere. So I think that is how we did it. No, we didn't use the internet. No. I think he asked if the data is in petabytes or exabytes, correct? They recommend, Azure team recommends the data size is very large. They have some SaaS facility, they called it Azure box or something, I don't know. They said that if the data size is very large, that alternative you have, we can move your disk physically from the here to there, and that will be much cheaper for you rather than transferring the data, because they also incur the cost to move the data. Yeah. Yeah, correct. Yeah. But that is, I think, a very large data, I'm just saying, correct? Because on our side, it was few TBs, and now network is so fast that few TBs, like we can transfer the data. Like now in our data center, we are using 10 Gbps of network within data center. So network speed has grown drastically, correct? So that's why I think we use that approach.
Yes, we use
Yeah.
migrated angles for this purpose only.
So I told you advantage of the yarn cluster is, let's say, if I say export snapshot on the production, that will impact production because somebody has to read the disk data and stream it. If the same HBase cluster is doing, it will impact the production. But the yarn cluster is reading the data from HDFS. This is not interfering with the production traffic. You can throttle it how much disk IO reads you want to do. You can keep a check on a disk IO. So there is a minimal risk if you use the yarn cluster. And apart from that, if you throw in more hardware with the yarn cluster, you can increase the speed of the data transfer. So I think that is the advantage you have with the yarn cluster setup. Even though, like, I agree, it may take more time. Somebody who doesn't know the yarn how to set up, that is the additional step. But if the data size is small, you can use very large hardware. So even though like you are transferring the data from the same machine, there is no impact on the production. Have enough capacity on the disk and CPU on the existing cluster and throttle your data transfer. So that is what you need to do if you don't want to launch the yarn cluster. No, no, we use open source HBase, our own installation we do. Yeah. No, no. So cloud we only bare metal machines.
So cloud to cloud migration.
Yeah. Cloud to cloud. Yeah. Different VMs. Yeah. Because otherwise there is no difference, correct? So if they share the same VM, yeah. I think I will skip this part. Export snapshot we already discussed via YARN. We stream the data. More hardware you put, you can increase the speed of the replication.
We already covered. Challenge.
Yeah. So we'll come over the last two slides. So this activity, maybe from the like approaches, it looks very simple. But when you are doing this on a production, for so much data, I think you need to have a lot of rigor. So we did couple of POC. We identify all the HBase versions we were using for different use cases. We set up the test clusters on the uh, different target clusters. We also set up a similar kind of test clusters on our source clusters. We installed in the same exact minor minimal version, Java version, everything has to be same, correct? And then we wrote the script, let's say, what is the behavior of this cluster? The writes are happening, reads are happening. We generated the scripts to generate that kind of workload on the source cluster. Similarly, on the target cluster, what should be the workload? And when the workload is running, we generated enough dummy data, and then we did this actual transfer simulation 2 times, just to make sure there are no gaps when it happens actually on the production, because there it has to be foolproof. I think if we mess on production, I think we don't have much time to roll back and everything, correct? So even though it looks very simple, it required, let's say, one or 2 months of time to do all these activities. So first things is, I think we are across the region. The first thing is, because it has lot of components, like you have master nodes, you have name nodes, you have data nodes, you have zookeeper. So one of the things you need to make sure when you're streaming the data from YARN cluster to another port should be, for source cluster to target cluster, all the ports should be whitelisted and they should be able to communicate very seamlessly. Otherwise, somewhere you will face the issues. To identify all the ports across all the components, and connectivity should be seamless. You should be able to do telnet across them. That is very, very important. Second thing is, I said you can you can do vanilla transfer from the HBase, but better to use the YARN cluster just to minimize the impact on your production, and also to increase the speed if the data size is very large. Third thing is very, very important is throttling. So what we did is, like Anshuman talked about third approach. What we did there is, like, you take a snapshot and immediately you enable the replication. So when we say enable the replication, replication is not happening, but it is buffering the writes on the transaction log. So I have enabled the replication and paused it. That is what. So I have taken the snapshot. Anything that was coming after that is going to transaction log and is getting accumulated. So I transferred this data. Okay. Then I will enable that replication after that, because that data has not moved, because only the snapshot data has moved. When I enable the replication, it is very important we throttle that replication. Otherwise, what is happening? That replication is happening on the actual source production cluster from the your transaction log and writing the data to the target cluster. So there is a throttling configuration in the HBase itself. You can say, like, how much Mbps of the data you should read during replication. So otherwise, what will happen? Suddenly, lot of data has accumulated this side. If you enable replication, it can choke whole of the network of the source cluster. So you may have impact on production. So that is very, very important. Throttling of the replication traffic that is happening. Sometime what you may also have, there may be lag, but that will catch up sometime, let's say during off-peak hours, but you cannot impact your production. Second thing is also very, very important is checksum. If the data transfer from one place to another, the data has to be very, very accurate and consistent. So there is a checksum property that you need to enable at the HBase level. So when it is transferring the file on the snapshot to everywhere, it creates a checksum metadata, and on the source it validates with the data payload if the checksum is right. So then it makes sure that the data that was from the source is valid in the target cluster. So this is very important from the data consistency validation point of view. Otherwise, maybe if some data corruption happens, you may have some issues on your target cluster. So I think I will ask Anshuman to move.
So as Sanjeev talked about the replication throttling part, I just want to cover there are two things, right? One is the replication, another is the export snapshot. So with the replication throttling, we should also throttle the export snapshot part, because as Sanjeev told, right, we have a limited set of pipe bandwidth. We can't, and it is basically used by the whole production. So we can't choke it and make sure, like, we don't want keep production shooting impact with the other application also, right? So there are two basically parameters which export snapshot provide. That is the mappers, and there is one is the bandwidth. Mapper basically provide ki like how many basically you want to split the task, and the bandwidth basically give us the how much Mbps basically you want to send the data. And other thing is ki when you are using the yarn cluster, there are some configuration for the yarn cluster also, like what the resources you want to give that cluster. So if you give like less resources, right, it won't be able to cope up with the parameters you have given. Then I'll come to the next part. So basically, this is actually we have seen an issue. So when we were doing the migration and all, and there were basically one node basically we wanted to restart it due to some reason, and because of we like it is in transition state of my getting the data, we killed it without giving some proper gracefully shutdown command, and the data got corrupted, and it made very difficult to again basically fix it, because we have to go to the SDFS level and fix that corrupted block to make sure that then now the data is again consistent. And then as Sanjeev told about the replicational part, right? The thing is why did we disable the replication? Because we haven't seen much blogs where they are specifying we have to disable the replication part, because there is a whole log cleaner process which is running in the background, which cleans the whole files regularly, because the mem store has already flushed the data to the disk, right? Now there is no required of whole file because it is used just for the data recovery part. So it will clean that file. So basically we don't want to that happen. So we'll disable the replication, though then log cleaner knows key it doesn't have to clean that. But there still is one other configuration basically, which is a global level. We have to configure that also to make sure it doesn't, let's say it is very large value, like I think 5 or 7 days or something. If it comes to that part, then it will clear it. So we have to configure that part also. Then when we are keeping the whole files, right? If it is in TB's data and you have a good amount of resource, then it's not a big issue. But as we got question of petabytes of data also, right? Then there can be a lot of whole files can come into the picture, and the data size can grow, and eventually it can make disk issue can come, because the size has been basically disk can be utilized 100%. So we have to make sure ki replication time and the whole size is coming. Basically you have to cross check it's not taking that much time. Then the last part is key whole files for each region server we have to keep in HDFS. So the reason behind is key, let's say key one server goes down, right? If the whole files we are keeping in HDFS, then it can use the replicated part from the other server and it won't hamper the migration part. Then replication process can overwhelm the mem tables if the basically the writes happening on the source cluster are very fast. Then target cluster can have a lot of writes, and then memster won't be able to cope up with it, and then eventually it has to delete the flushes, and eventually the process will get killed. So those are the few learnings and challenges we have faced. We used 150 for our. No, there was no aggregation, so we didn't use any reducer. We use 150 of the mappers, and we use around 400 Mbps of the bandwidth.
Like that, you had the option to. You had the option to.
Again. We haven't gone to in very depth of moving the disk, because it like if it would have been data in petabytes or something, right? We would have considered it. But it's on TBs, and while we're doing the POC, right? We
You're talking about disk block sector level, right? He's talking about like Azure has the like something like ASR you're talking about, right? Where Azure does a disk to disk replication. Why we consider that is what?
No, so I think just want to highlight. So disk to disk replication you can do, but so what we are doing is we are using H-based tools, correct? So some of the things, let's say disk to disk, it doesn't, it's not aware of, let's say, what is inside it, correct? So H-base also takes care of, let's say, this is my H file. I need to validate the checksum, correct? So it knows more details about your data and it takes, make sure that everything is right inside the data. But if you do block to block transfer, you are taking care of like block to block, correct? So I think, yeah, throughput, I think we have to throttle. I think we didn't like throughput was a limitation on us, correct? So because we have dedicated pipe, so that's why we throttled. So we didn't have. I think it was only 1 Gbps of pipe we could use. So that was not a available bandwidth to us.
Do it in a production system where it is running, right? And you have a limited, and this was over 2 regions.
Yeah.
And there was, we're talking about this. When you have an offline system, when you want to, but you need to distribute, there is always a, you should have a downtime for it because you should wait for that to come up, initialize, all that things, right? But here it is like seamless.
We have to do immediately cut over within 15-20 minutes. So I think 15-20 minutes downtime we still took with the replication because we have to disconnect the replication, make sure validate, run our sanity script application is right, incrementally move the traffic, correct? So we still took the time. The downtime was still there, but we minimized the downtime with this approach. And we did it during night time, early hours, because Myntra is in India, so we have that luxury that we can still do something in the early hours of the day, 4-5 o'clock. But if somebody is working in a global company, they need to see every time they'll get the traffic. So yeah.
Other questions?
Yeah, you also mentioned in the beginning that there was some data that you decided as not as important to be migrated, right? Can you throw some light there also?
Yeah, sure. In analytics, one of the teams processes a very large amount of the data and puts the final aggregate data into HBase, and they power some internal dashboard for some analytics kind of use case, correct? And that is used internally, and that data is processed every day uh, from our processing pipeline. So there, I think we have let's say if we don't have the data for new data for next day, we are okay because our internal teams are looking at those reports. I think that's why I said that was the use case where we have enough leeway. We can take full snapshot, pose that job. So it will not process the data. When we move there, we'll process the data for full 2-3 days in one go, correct? Because we have raw data always. Yeah.
We talked about data being migrated from one region to another, right? So can you please share any insights of why was this particular migration required? In addition to that, were there any optimizations that you did, as in how the data was being stored or being utilized with respect to the earlier configuration and the new configuration that you did?
Hello. So I think I will just give you an idea why did we moved it. Because we are on cloud with Azure. Uh, Azure has decided that initially when they came in India, there was one region. But as the customer grew, they said that this would not be our hero region. So they have some concept of hero region where they have all the different kind of services readily available and the new features get launched there also. We also wanted to use GPUs. Another thing, what they also did is when they created this new data center, new hardware was provisioned into this data center. And they were saying if you move there, they were giving around 25 to 30% of the cost benefit to us. And and this was one of the initiatives that we wanted to bring our infra cost down. So that was another thing. Azure anyway wanted to move, but people were reluctant. So they were pushing with the cost benefit, that 30 to 40% cost benefit you will get if you move, because this is a large exercise. Every company will require a lot of effort to move. And they also helped us in the movement for their SaaS services that were there. So that was the context behind why did we move. Second thing, what you said is like what configuration changes we do when we moved from here to there.
One of the thing was key in the source cluster we use SDD as a disk type, and in the target cluster we use SDD. So because basically when we were doing the POC, right, we found out that we are seeing very good improvements in the read and write. So basically most of the writes and reads were going to the disk, right, during the POC, because we don't have any cache and at that time. So we saw there are a lot of huge improvements. So then we shifted to the SDD in the target cluster. That was the one of the changes.
Yeah. Bare metals means VMs. Yeah. Yeah. Yeah, we have some part dedicated, some on demand. Yeah. No, I think they say that you can use this capacity. The costing is different for dedicated, on demand costing is different. But that VM can go down, that your data is always attached to the EBS volume. I think
So that's
Srini.
standard VM. Standard VM.
Yeah, standard way. Yeah, standard. Srini, you want.
Yeah, so they have also.
Even though it was dedicated to Mintra, but was just that they allocated, okay,
Yeah, thanks to Sanjeev and Anshuman for the great one. I think if you have other talks, questions, we'll take it up later because we are really running behind the time we're supposed to. Thanks, Sanjeev and Anshuman.
Thank you.
Okay, so I will now request. Actually, I did a mistake. My apologies. Punnami Palaniswamy was supposed to go at 2 o'clock, but we did a swap. Yeah, please be on stage. So we'll welcome. Well, another HDFS, DFS. So basically, similar talk, but in a own data center scenario. I think LinkedIn is slowly adopting. Azure as well, but they have a lot of their own data centers at the same time. So we'll listen to this one. And this is improving data redundancy and rebalancing in 2 exabytes of data on HDFS. So the previous one obviously was moving from one data center to another data center. So it's a transfer problem. This is a rebalancing problem. And at 2 exabytes, I think this is a serious problem. So let's learn from Punnami. Can you check them?
Sorry. It's on. Yeah.
Yeah, you are audible. It's okay.
No. I don't need it. I mean, yeah, I have it in local.
Data. It needs internet, right? To connect to them.
Yeah.
Which one? When I have a tethering. Let me disconnect this.
Take the WAN network, it was easy.
I don't. So there is no wireless that I can connect.
Type C लगा दो ना.
Okay. Okay, I mean, let me check whether that. It doesn't connect. Icon. Yeah.
Just there, allow. Okay, is there. Just share the.
Yeah, that one. The entire window, there is only one.
Okay, you are there.
Okay. Am I audible? Okay. Good afternoon. Oh my God. I hope not a lot of people have fallen asleep already with the good food. So I will just introduce myself. My name is Ponmani Palaniswamy. Been with LinkedIn. I'm working as an SRE, predominantly taking care of the data systems in LinkedIn. Apart from, I joined LinkedIn almost 2 years back. I have total 17 years of experience doing the work of SDE and SRE interchangeably every 4 years throughout the last 17 years. So that said, I'll be talking about, we all know the typical distributed systems when the scale gets very high, and then if you go and see all these cap theorems and everything, the redundancy is for read and write patterns. So the moment if you don't really consider the redundancy for maintenance, what happens, and then what sort of tangle we got ourselves into, and then how we came out of it. So I'll just give you a context of what is this entire big data ecosystem in LinkedIn looks like, right? LinkedIn is very high on a lot of artificial intelligence stuff that is going on, right from the jobs that you are recommended, from the people that you are recommended, you might have to connect, from the articles that are generated by the AI, and how to kind of identify the right possible collaborators who can collaborate with this AI-generated content, to content validation. If you're uploading something, you have to ensure that it is not having any sort of redundant content or illegal content on it, right? So all these sort of things, there is a lot of AI pipelines that are running, been running for some time now, even before GPT came over and then took the world over. This has been the case. And then most of it, 85% of these pipelines are fed by big data, the data in Hadoop ecosystem. So the thing is, we ingest more than 2 petabytes of data every day to Hadoop. And then the minimal retention time is 18 months, and then the max is 10 years. That means we have 2 plus exabytes of data. We have kind of moved from terabytes and petabytes now into exabytes. And we have around 10 production clusters, which is taking care of this data. And the largest of these clusters, which is having 12,000 worker nodes. These are not virtual machines. They are not containers. They are bare metal servers having 512 gigabytes of memory. And every one of these data nodes is holding around 70 terabyte of data. And then, yeah, the typical amount of data in the largest cluster is 800 petabyte. We have this spanned across 480 racks. I mean, folks from Myntra, they touched upon HDFS pretty lightly, saying like that is the underlying infrastructure which is powering HBase. I will have to get bit deeper into HDFS itself here. So HDFS is once again a part of Hadoop ecosystem. It's the data part of it. Yarn is your compute part of it. I've just kind of summarized it here. It's not exactly the stuff, but it is a summarized, condensed version of whatever is in HDFS, right? There is something called name node that is a control plane, which kind of takes the request. It has the metadata about where every single piece of data lies in that entire cluster. And it coordinates with something called data node, whose only responsibility is to read data, write data, replicate data. And then every single data node will be having its own local disk. We use NVMEs. There is no network storage and stuff like that. That doesn't work for this sort of a scale. And every single piece of data is usually replicated thrice. In Hadoop, it's big data, right? You write a file of size multiple gigabytes. So it doesn't store everything as such that. So it has to chunk it in terms of fixed size entities. It called as blocks. So yeah, it's a three. I mean, some clusters it's 3 name nodes, some clusters it's 5 name nodes. It also has a journal node setup that is also highly available. 3 to 5 journal nodes. So I'm kind of summarizing it or condensing it because otherwise everything is highly available. The usage itself is the max is 85 terabytes, but we have 128 terabyte mounted on every single data node. Right. Yep. Right. That's the usage. It's at least double the size of it. We have somewhere it's 200 terabytes. Now we are going towards 400 terabyte disks. Single name nodes, single data node. Single data node, yes. Okay. It's all bare metal. We are not on cloud.
Just a curious thought. Can you vectorize SDFS?
Sorry?
Can you vectorize SDFS file system?
Vectorize in the sense?
Instead of you converting data into local disk, before persisting, can you store the data as just a vector?
Where?
Yeah, before putting into memory.
I mean, it can be, the data can be anything,
Yes,
right? It can be an image, it can be a video, it can be a text content. It's a huge one file. How do I persist it with redundancy? I cannot persist a 100 GB file as it is on a single disk, right? I mean, you have to kind of chunk it. You have to kind of partition it. I mean, that's how even your typical videos for YouTube is stored. It's not a single stuff. It's like into multiple chunks of 5 seconds to 30 seconds, and then everything has its own metadata. Everything aggregate to a single video ID. So that's how entire large file objects are persisted everywhere, right? So I don't still understand what do you mean by vectorizing the data. The data is data. We cannot just transition the data from one to another. We can discuss offline if I don't understand it correctly. Yeah. So now we kind of talked about how files are written as blocks, fixed size blocks. I mean, you can see what is the typical size of a block. It's usually in like 64 megabytes. Yes, it is. Yes. Yes, yes. Sure. Correct. Correct. Absolutely right. So HDFS calls this as block placement policy. That is the strategy it uses. Okay, if you have n is the desired number of replicas, where should I put it? And then how can I choose a target node from this n number of data nodes? How to put it? That's the strategy that it uses, and it's a pluggable, swappable strategy, in fact. So we have 3 replicas. That's itself is kind of killing us with this amount of data. You have to replicate it thrice, and then in here there is no active, passive, primary, secondary, master, slave sort of a thing. Once you write the data, nobody knows what is the primary copy. Every single copy is equal. It has an equal weightage throughout the entire cluster after it is written. So the default stuff that comes with Hadoop for a different reason, that's what we were using until last year. That is like have three replicas in three different data nodes, but ensure they are in two different tracks. So you write the first replica in the node 1 in the rack 1. You write the replicas 2 and 3 into node 2 and node 3 rack 2. So that way you will be able to lose an entire rack, still will be able to retain one live copy of that replica block so that you will be able to serve it when there is a read or a read job happening there. So this is an indication of how it is. Like I have just declared three different racks, every rack having two different data nodes. That pebbles of different colors is like a replication of that particular block. So if you can see, uh, the purple has first replica in rack 1 in node 1. The second and third replicas in the second rack. The same way everywhere, right? So this is how it usually is. I've just kind of given only three racks here. If you just expand it to like hundreds of racks with every rack having 30, 40 servers, then yeah, you understand volume of it. It's all good, right? I mean, whatever we have seen so far, you take down the entire rack, even if you lose the power connection to the entire rack, it's still available for you to read at least one copy. But the problem is maintenance. This entire stuff was designed for read and write. Okay, for what is sort of, why are we not storing in three different tracks? Because you have to replicate across the network for three different tracks. So we wanted to kind of optimize for the write, and then initially the HDFS went for that sort of a thing. It's like co-located storage plus compute, and then you have two racks for redundancy. But the problem was with maintenance operations. So when you want to do OS upgrades, these are the typical planned maintenance operations, right? Or your OS upgrades, your top of the rack switch upgrades, and then rolling updates to the software. Even though it's Hadoop is open source, LinkedIn uses its own variant of Hadoop. We have forked it and then added quite a few things for our own auth purpose and different purposes. So we do keep rolling out new features to our Hadoop ecosystem, almost all the components pretty frequently. So I'm still giving some sort of context, and then when we see the problem, we'll understand what is the problem because of the large volume nature of this. So when you take down this data node for maintenance, Hadoop recommends you to do it in two ways. You can do it in two ways, in fact. One is you decommission selected set of nodes. Let us assume I want to maintain a rack. I want to do a switch upgrade on one of my racks. I want to take down all the nodes inside the rack. While doing it, you ensure either you go for decommissioning of all the nodes. Let us assume 40 nodes inside the rack. Or you do for something called maintenance mode. So what decom says is every single replica of every single block in the chosen data nodes, you replicate elsewhere. So that even if you discount all these 40 nodes, still every single block in the cluster has three other live replicas. That means if I'm having like 70 terabyte in 40 nodes, you just replicate 70 terabyte into 40 amount of data over the network to some other nodes. No, three. Sorry. Yeah. Right. And then there is this excess replica removal kicks in place whenever a new, existing node rejoins the cluster, the existing replica is identified and then it's removed. It's removed. Right. I mean, it's not old because it's immutable, but yeah. We just, yeah, remove them. I mean, we kind of tag this as this is an excess replica, and then you remove. Absolutely. Right, right. Absolutely, yes. The other one is maintenance mode. There you kind of sort of relax your condition a little bit. You say like, okay, as long as I have two replicas of every single block alive somewhere, I'm okay to take down something. So in that case, if I select 40 nodes once again for maintenance from a rack, all I have to ensure is like for every block inside those 40 nodes, is there at least two replicas elsewhere out of these 40 nodes? If so, I don't have to replicate. If so, if not, then I have to replicate just enough so that I have two other replicas, not all three replicas. Two, yes. Right. Right. In this way, when you bring this node once again back, because it has the data, it can rejoin the cluster without doing anything. Right. So these are the two ways that you do it. I mean, decommissioning is obviously ridiculous to do at this scale. Nobody has to do it. And then this is a typical state transition, how it happens in a data node, right? And then the name node coordinates it. So The same thing I have explained using diagrams here, the same sort of things with 3 racks, 6 nodes, 3 blocks, 9 replicas. If you see the one with decommissioning, even if you take these two for maintenance out, still you will have those 9 replicas out. Whereas in the maintenance mode, it's not the case. Only if you're having, so here I'm having yellow block in node 1, node 2, both belonging to rack X. Only that has to replicate out in the maintenance mode operation. Yeah. Right. 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 You have to remove one more. Yes. Yes, yes. Whenever any node rejoins the cluster with some data, every single block in that node is checked for excess replication. Maybe you just reduce the amount you have to replicate out and then reduce the amount you have to remove as excess. That's all. I mean, we know decommission, it's like impossible because we're talking about 70 terabyte of data per data node, and then we want to do at least in hundreds per cluster at the same time for maintenance for different reasons. It takes 2 hours minimum for a single data node to drain all the data. So even if you are doing parallelly, the moment it increases the concurrency in terms of the batch size to be like from 40 to 100 to 200, it just warms the network. We have some sort of network pod switches, which is having the capacity of 3.2 terabits per second, 4 switches put together, and then we kind of reach 98% of the utilization. So it's like impossible to increase the concurrency with this approach. And then once again, if you have increased number of data to replicate, the checking of what to replicate and keeping track of those things to replicate, and once again removing, delegating to the right data nodes, it's all taken care by this name node, control plane component. Already we are having name nodes running with 375 gigabytes of heap. And then that goes with the GC passes for 20 minutes if this happens, if you increase the concurrency. So the name node once again is kind of always congested. I mean, sorry, stressed for the resources. Maintenance mode is tad better. We don't take 2+ hours. It's 30 minutes minimum. It's still okay. But once again, it's not like a zero replication, right? Once again, our velocity is constrained because how much we can bring down concurrently for any sort of maintenance operations, including new software rollout. With maintenance mode, you understand it, right? I mean, if there is only one node that you're taking down for maintenance, you don't have to replicate anything out because one node will have only one replica of any block inside that. The moment you add 2, there will be more. So the moment you add more and more to the batch, the amount of data that you have to replicate out exponentially increases. So this caused troubles in whatever we just talked about, right? Velocity of maintenance, we were unable to do it. I mean, if you cannot roll out software fast enough, that is bad. But if you cannot patch your operating systems, that internally we have set ourselves a target of like less than 45 days to do OS upgrade on every single component in the entire data center. We are unable to meet that. And name node resource usage is, once again, we are tremendously stressed. That is sort of an active passive name node. It's not active active. I mean, that's the entire architecture of Hadoop's name node. We are stretched for its resources. So the thing is, like, we wanted to kind of implement something based on availability, change the redundancy policy or the way it gets replicated using something more like tagging mechanism, right? So you come up with something where you can define n different zones and then replicate according to these zones, so that you have the flexibility of taking down n number of nodes at a given point in time for maintenance. We wanted to kind of go with 20 different availability zones, and then so that you can take down 1/20th of these nodes for maintenance without having to replicate anything. So that is up to 5% that you can lose still with running all the data intact. There is a problem with that. I mean, Hadoop even supports that in terms of, as I told, block placement policy is a swappable strategy there. You can even write your own stuff. They have something very close to this called upgrade domain. You add a tag or metadata called upgrade domain to each data node, and then it kind of assumes, okay, this data node belongs to this particular upgrade domain, and then it will be able to perform that. So it's as simple as adding, I mean, you stripe your entire fleet so with upgrade domains or availability zones. In a way, they are evenly distributed as much as possible. You don't want 20 upgrade domains, means ideal distribution is 5% for each zone. You don't want one zone to be having 20%, another one to be having 1%. So you kind of do that first, add this metadata of upgrade domain or to every single data node, and then change the config in the control plane, restart it, it should work. That's the easier thing to do. That's what the community recommends and everything. But I mean, whatever I've talked about, right? Upgrade domain BPP. Here, if you see, I have 4 racks, the same 4 racks, but I have 3 and 4. These 2 racks belonging to the same upgrade domain called upgrade domain 3. Means I cannot have all these 6 nodes put together. They cannot have a duplicate copy of any single block because they are upgrade domain aware. Yeah, please. It's upgrade domain aware. We have to make that. Yeah, so that's the approach that we wanted to take. It is. We will go there. We will go there. I will just talk to you about it. Correct. If you see the way we kind of stripe the upgrade domains is not at a node level, but at a rack level. So every single node inside a rack will have the same upgrade domain. So it is also rack aware plus something additional on top of it. It's rack plus plus. So we are going to give the upgrade domain to a node level. But the way we are doing it is like everything inside a rack will have the same upgrade domain. Right. So this is what the simple stuff, right? Do it and then it should take care of it. But the moment we did it, Hadoop starts. I mean, the moment you reset the Hadoop name node, HDFS name node, it comes up. It goes through every single block it has, and then check whether it is satisfying the block placement policy. Now the policy has changed. It will say like most of its data doesn't satisfy the block placement policy and starts replicating hundreds of petabytes of data at the same point in time. Means catastrophe. It's the GCN's high priority, high severity stuff that brings the entire site down. So we couldn't do it. That's the sort of thing. So how do you do it? I mean, the SDE in me, the very first thing it thought about was like, hey, go and change the Hadoop. Let us make changes to Hadoop. Right? Once again, a stupid decision to do because you can do it in 2 ways. One, you ensure every single new data that is getting created gets replicated using this new upgrade domain based block placement. But you kind of put in checks and balances so that the old data, it doesn't do anything about it. It's not as simple as it when you heard it. It's much more trickier, a lot of cases. But I thought like, okay, let me do that. Or let me do it in a way like, okay, let it do whatever it is. But the only problem I have is like it replicating all the existing data at the same time. Can I put some sort of instrumentation, let it watch for some other matrices, based on it, let it throttle it? It should work. I had some sort of code change, written tests and stuff like that, and then understood the sort of how it's sort of central nervous system, this particular block placement policy in Hadoop. The amount of things for which it is used, right from new data creation to block report, whenever the data node sends its reports, whatever it has, it processes it and everything. Whenever something goes down, whenever something rejoins it, whenever you change this name node from active to standby to observe and then change it back, everywhere it is used. And then on top of it, adding an external instrumentation client here. Like we have a lot of graphs and matrices, but adding something like that to core Hadoop, it is like it's really, really performing some sort of a neurosurgery, right? So that is the reason we once again started thinking about the amount of testing that it takes to do, not only in terms of functionalities. Hadoop has good code coverage, test coverage, and all, but even to enough in terms of the network utilization that it can trigger, in terms of CPU utilizations, number of threads that can go into IO block state when one of those upstream metrics clients is slow or anything like that. It's sort of insane. So we had to think around, is there a different solution that we can tackle, that we can use? Yeah. I mean, we make changes in Hadoop for different purposes. Usually you don't go and change one of those top 3 core functionalities which is used across the board, right? You don't usually do that. So even when you say, No, so that's what I'm saying. The version increments that we do on top of Hadoop, it's not for this sort of core changes. Actually, you change your auths from Kerberos to something. You change the way the journal node sharding so that it's like from active passive to you go to multi-active when you kind of restore the checkpoints and then restore that sort of a thing. Usually you don't go and make these sort of changes to open source components because there is already a policy that is pluggable. Only thing is like we have to kind of, we're going to use it, but we want to kind of transition into that policy without really impacting a lot of things. So even the active development that we do on HDFS, it is not on these lines. It will never be on these lines. We will take it offline. So we kind of get a bit deeper into that. If you see the upgrade domain block placement policy given by Hadoop itself, this default block placement policy, that is a rack-based block placement policy, plus 3 replicas on 3 different upgrade domains. It ensures that. It is a subclass of block placement policy. It does like super.validate, validate my parent class's block placement policy, that is the default. On top of it, also validate whether it is split across 3 different upgrade domains. Means halfway through, you find an issue and then you want to roll back. The rollback doesn't take any sort of re-replication of data because it is already satisfying the old placement policy as well. The second thing is like any data node, if you don't associate explicitly an upgrade domain to it, it will take its IP address to be the upgrade domain, default upgrade domain. That means if I just, let us assume a 100 node cluster, if I just give upgrade domain for 10 nodes, the remaining 90 will be having their own unique upgrade domains. Means there won't be any replication happening for the data inside those particular 90 data nodes, only in these data nodes. So we just wanted to kind of leverage this nuances inside the upgrade domain block placement policy. And then, okay, let us rebalance data in n data nodes at a time, batch by batch. This should be working. Only thing is like it will just go out of these 10, sit elsewhere. And then once you migrate, add upgrade domain to those, once again, it might move out. So it might have more hops eventually before it settles down to the right data node. But the thing is, it's non-invasive. And then what we are doing is, anyways, every single day we are doing OS upgrades because of the size of the fleet we have, 60,000 nodes. We are doing OS upgrades for at least 300 machines every single day, 200 to 300 nodes. So why don't we just piggyback on top of it is what we identified. So we built ecosystem and orchestrators so that we could piggyback on top of this maintenance operations. Just do the additional step of adding the upgrade domains, fetch it from the inventory that you have created, apply it, and then go for the maintenance operations. No, it's not like that. So how Hadoop takes this metadata, unlike some cloud systems where you add a tag, like it's exactly like this here. So you have to give a metadata in a configuration file saying like for this node, this is the upgrade domain. If you don't explicitly specify it, it will take its IP address to be the upgrade domain. Upgrades, yeah. Right. It doesn't have one. Right. No. So this is what you wanted to do, right? I mean, you always have this batching logic. It understands how to batching. It's once again a swappable logic. You can select everything from a rack. You can pick one from all the racks. When we are now going to change it to kind of pick everything from the same upgrade domain. So this strategy of picking nodes to put it inside a batch to do a maintenance operations is sort of already configured. So I mean, Swapper, you can write a simple line set of code and then it will handle that. And as part of those picked up nodes, we do some sort of maintenance checks and state checks, and then you bring them down using the maintenance mode that we talked about. Not using full decom, but the maintenance mode. Before these two operations, you just add the upgrade domain information to those nodes, ensure the name node becomes aware of that, and then go for the maintenance mode so that it starts replicating the data. Yeah. Right. Everything is in a single cluster. Yeah, go on. Yeah. Right. Yes, yes, because even for, yeah, go on, go on. It is happening even today, even without this upgrade domain and all this nonsense, because we want to do a software rollout, let us assume. I want to take 100 nodes down. It replicates the data out from these 100 nodes. There is no extra read, right? Yeah. Yeah, let us take the worst case. Right. Okay. So what we do is we take the same 12,000 nodes. For 100 nodes at a time, I add the upgrade domain. As of now, all 12,000 don't have any upgrade domain metadata. They have data. Yeah. So I still don't get it. How is it any different? Yeah, sure. Because it's on the peripheral, it's not into the central nervous system of Hadoop. I cannot say everything is hot, but the problem is it's difficult to, I mean, we can understand what is the hard data in terms of which file is hot. But the problem is it's all blocks. Hadoop HDFS doesn't understand files at all. Only the client, when it requests for a file, it will say these are the blocks for this file. And then the way it is stored across, right? I cannot say like, oh, this data node has 90% of hot blocks. Yes, yes, yes. I mean, there is some hard disk. There is some hard disk, but yeah, 90 plus percentage is NVMe. Absolutely, yeah. So the problem is the compute jobs don't distinguish in terms of how old it is. It's more about like how valuable it is. Right? So, I mean, I once again simplified. This is handled using multiple different services and system calls and IP calls and stuff like that. But in general, sorry that I put a pink background on this block. That is the new stuff that we wanted to do as part of this process. But you can see what it does is whenever, so the OS upgrade itself is a huge stuff. There is an engineering blog written on engineering blogs.engineering.linkedin.com. You can read about it. So it kind of fetches all the nodes that needs an OS upgrade and then submits it to another system. And then it does some sort of a batching logic. That is once again a pluggable. We have written multiple batching logics, everything from a rack, one per rack, or everything from a GUD going forward. So it says like, okay, I can safely do 200 nodes today. And then it gives the 200 nodes. And then you go and understand like, okay, whether these 200 nodes, once again, split across multiple clusters. For every single cluster, you see, check like whether it is okay for me to take down these things, whether there is an outstanding alert, whether they're having some sort of misreplicated blocks already, maybe there is already an issue going on. A lot of HDFS usage, whether it is already 90 plus percent and stuff like that. If it passes, then it was doing, okay, the safety check passed, now let me go and put those things into maintenance mode, wait them so that all the blocks are replicated out. So the state transition moves into in maintenance state, and then you bring the machine down, I mean, shut down the process, bring the machine down, gone, please. We want to have that flexibility. Will we be able to do that? That's another question. We cannot afford to lose that much of capacity. But the thing is like, the problem is going to be the capacity, not the time taken and the resource utilization. Yeah, so those are all kind of solved with this. But the problem is, will I be able to lose 5% of like what, 12,000 nodes is 600 nodes? Okay, there is another variable on top of it, which I'm not discussing here. The entire compute runs on the same set of nodes. Yes. We are disaggregating, but it is in progress. At this point in time, it is shared, co-located. But the problem is, if it is 12,000 nodes, 95% of the time you fetch data remotely from another node because you don't have the data. The core principle of HDFS to have the compute and data on the same machine goes for a task if you let your clusters to scale like this few thousand nodes and all. So that's the reason we are also working on disaggregating compute from storage. There is also a wider initiative, which I will not be able to share at this point in time in terms of moving to the next generation of HDFS, dumping the HDFS itself. Probably sometime later, we will be talk about it. Snowflake is a service, right? The service offering by public clouds, right? Is it? We are on data center. Right. Yeah. So we are not on any public cloud to leverage a lot of these things. We were unable to go to public cloud because of a lot of reasons, a lot of investments that we are making elsewhere. So we are talking about 400,000 nodes of the volume that I mentioned, the sort of configurations that I mentioned. They have to build data centers for us, so we had to park it. Yeah, there is give and take, but we are not moving to Azure as such. So that's what we are doing. It's essentially a very simplified workflow of whatever I just explained about, right? And then we are also building a standalone orchestra as a fail-safe one. And there are some clusters which are like few nodes, but a lot of blocks, because we started writing for some use cases logs into it, like 10 megabytes, few hundred kilobytes of data inside that, abusing HDFS. Somehow we did it and then became so mission critical. For that, we are also creating a standalone orchestrator. You have to don't know worry much about it, but it has to kind of integrate with all the other components. There's also upgrade flow. There is a rolling update for deployment flow. You cannot just go and stomp on each other. You have to have some sort of mutex, distributed logs that you have to hold on to so that they don't intervene on each other. So we have built that as well. So with this, that's the target. I can take down up to 5% of data nodes without having to replicate anything. Will I be able to afford to lose 5% of my capacity at any given point in time? It is definitely not an is, but it's definitely much more than me taking 6 hours to do maintenance on 100 nodes. It's going to be like much, much faster. Time to, this is what I was talking about, right? We need at least 30 minutes in the best case and 2 hours on an average case so that you can prefer to go to the very first step of the maintenance. Just to drain the data, it was taking on an average 2 hours. Now it will be kind of 2 minutes going forward with this. And then name node heap usage. Because this is such a huge operation, put tremendous stress on name nodes, that is also reduced now. Name node is your concept? Okay. So it is having 128 CPUs. It's having, I think, 512 gigabytes of memory. We are using 400 gigabytes of heap configured. Yeah. So this is from a test cluster, not a prod cluster. You can see the heap usage, GCs, top of the rack switch, network utilization, everything is better with this when we go for maintenance operations. Yeah. Sorry? It's on Linux. Now we have migrated to Mariner, that is Azure's Linux. We were on RHEL support ended, so we have migrated to Mariner. Mariner is Azure's Linux.
Go ahead, because you will have questions like you won't be able to proceed.
I mean, these are the resource utilizations, right? The max heap usage, because it was having 4 different name nodes in a high availability setup. The max has come down after we kind of did this. It's all test cluster data. That's pretty much. I don't know whether I have time to take additional.
We really don't have, because Q&A were happening, and the moment you started talking, Sachin was thinking about his cluster, so what he used to manage at Yahoo. Okay, so all those folks were doing the same. So I'll invite Roland now, and I'm pretty much sure Roland was also dreaming, but then being selfish that when his talk gets in, he didn't ask question. Go in, Roland. Thanks, Punmani. Thanks a lot. And most probably, this is the thing where we start naming this meetup as large-scale production engineering. That's the scale we operated at some point.
Remote folks can hear me?
Remote folks? Remote folks, audible? Yeah, you can, you can. Testing. Okay. Testing. Meeting. J, G, E, H, Z. Ask to join.
So request speakers and all to stay till the end. We have some goodies for the speakers and obviously for all of you attending. Thanks to our sponsors. Don't leave early. Thank you.
Ask to join. Okay. Great. To share my visible remotely? I hope so. Okay. Just give me a moment. Get my notes. My okay. So I'm the last speaker. I won't keep you guys long. Hopefully not very long. Okay. I won't keep you guys very long. I know Saturday we need to have a beer too. So let me take about 20-25 minutes. Also, I know it's the last talk, so I'm going to be a bit light on tech, maybe talk a bit more about the process and some tips and tricks. Okay. Yeah. So the thing I want to focus on is given the recent, I wouldn't say recent, about year and a half back when money dried up, right? People started losing funding and all of that. There were many folks who started cost rationalization. Even we at Rubrik, we went into a bit of cash conservation mode, and then we had this immediate thing that, okay, do something about your cloud costs. And for us, that was a late task. We had already planned out our quarterly OKRs. We had started work on our OKRs, and then our CTO said, do something about cloud costs. So it basically meant, okay, we had to fit in this somehow. So our focus was on what can we do quickly? What can we do that has good impact? And how do we make it sustainable for the long term? And this basically means you have to make calls that basically say, okay, how much time do I spend on this? How many people do I need? What can I do very quickly? So this may not sound very interesting from a SRE point of view. So the point I want to highlight is that when you are faced with such a maybe trade-off that you have to make or reprioritization you have to make, there might be some tips that you might find useful. Okay. So again, repeating, this is a bit light on the tech, but I'll describe enough of our tech to provide the context. Okay. And I'm going to talk about a segment of what we did. So this might be very relatable for folks who manage data platforms. May not be your whole infrastructure, but focused on data platforms. Okay, who we are. Rubrik is, I'm not sure how many folks know about Rubrik, but very quickly, we are a B2B company. We sell stuff to the enterprise. We are not a consumer company. What we sell is, traditionally, we started life as a backup company. We used to sell hardware. We still sell hardware to enterprises. They deploy this in their
let's say on-prem or their data center environment that takes backups. We started life taking backup of when VMware and Nutanix became very, very popular 10 years back. If folks remember that, server sprawl became VM sprawl, and that time we needed, folks wanted data protection solutions. So we started life doing that. And as enterprises and many startups today have changed the application architectures and moved to the cloud, we also have solutions that sit in the cloud, as in your cloud environment. For example, we sell software. We don't always keep hardware in that case, but we give you software to again do some amount of backup. And we have moved beyond backup. We got a copy of your data. Can we do something smart with it? So we have added a bit of data observability around that. Who can access what of your data? So there's a bunch of nice features that the security folks, your CISOs, your CIOs would definitely be interested in. So it says data observability. There is also data observability in the data platform land. It's not the same. So this is more around who can do what from a security point of view. Yeah. So moving on, I just spoke about our products and solutions. So you see that we have this hybrid infra model that we address, right? Sell on-prem stuff and the cloud stuff. This is a growing business, thankfully for us. It's a growing business. We have around 5,000 odd customers. We have about 15,000 on-prem installs. I'm calling them clusters because it's easier to talk about it that way. And those installations are fast approaching 100,000 nodes right now. This is something that we sell. It's not something that I can control and reduce. It's what people buy. If people love the product, they're going to buy more of it. I can't do anything about it. We make money off it. Okay. So again, that's what I said. This may not be directly relatable to SREs because you say, oh, this is on-prem thing. What am I going to do with it? But the thing is that we bring a lot of data back, and that's what I'm going to talk about. Also, there's a control plane that we use to manage all of these. That is a product that we have built and deployed in GCP. We are on GCP. Actually, we are on all three clouds, three major clouds. We are in GCP. Our control plane sits over there, and our SRE team basically focuses on building that out. That's our SRE team. I'm not going to talk about that. That SRE team is started small. It's growing at the moment. I'm going to talk about what we do. Marvel fans might know the background image. That is something called Jarvis. Our team is called Jarvis. We basically provide services and capabilities that allow the rest of the engineering org to basically extract, to use the business buzzword, intelligence out of your data. So what we do, to keep it relatable, we bring metrics back, we bring logs back. We also bring a lot of data blobs back. And our goal is basically use this to serve three major constituents. One is product management. They want to know how certain features are used. What do? You basically query this data set that we have. So we have applications built on top of that. Another feature, another major consumer of this is basically, as I said, we sell stuff to the enterprises. Like enterprises want support, so we have a support org that again consumes the data and the insights from the data. And finally, again, typically in enterprise products, if something goes wrong, they contact support. Support is not able to make progress. They come to engineering. Then engineering also wants to query this particular data. So those are the three major guys who want to look at this. Our goal has been to ensure that we optimize these processes, optimize support processes, as well as optimize product management when they want to think about, okay, what is the next feature we want to build? Yeah. Quickly touching up on a tech stack, as I said, we're on the three major clouds. We are heavily on GCP and AWS at the moment. Some of the stuff we are trying to move out of AWS to Azure. We are heavily biased towards managed solutions. It's a mix of buy versus build, very little self-managed stuff, a lot of stuff provided by third-party vendors and cloud vendors out of the box. There's some homegrown stuff that we are, again, personally, I believe that things have matured enough that we can think of retiring those and moving to fully managed source. Open problem that we have, as I said, we keep selling stuff. How do we manage, because the focus is on costs, how do we ensure that our costs are manageable with growing business? So where are we going? As I said, we are trying to move towards maybe more and more managed services, and hence we are trying to also think about creating a additional SRE sort of team that will help us manage stuff in the public clouds right now. So that's us. Now let me talk about the problem I want to describe over here. It should be visible. So the logos should be pretty much identifiable, right? So that top left box is basically what we sell to people. So this is in the customer environment. This is either on-prem or in their cloud environment. And then that ships a bunch of data. I'm focusing on, as I said, blobs at the moment. So we upload blobs at a regular frequency, some of them on a daily basis, some of them on an hourly basis. They go and sit in S3. Then we have a queue in the middle, some stuff happens over there. Then we basically have a EMR cluster that basically runs Spark jobs and tries to extract some out of those blobs. And then we basically do some processing and then push it to Snowflake. We use Snowflake. So if you see here, a lot of managed stuff, very little homegrown built by us. And data folks will realize that this is basically a ETL pipeline. So it's exactly that. Get data, extract something, transform it, load it into a warehouse. About scale, so we get around 2.5 million odd blobs per day, totally about 73 TB. This is growing, as I said. If we were to not, if we were not to add any more data, just the fact that I sell yet another cluster means that number is going to grow. So I'm going to focus on two specific pipelines here. There are multiple pipelines. One of them is basically, as I said, engineering works with this data, right? So one flow is basically you take a blob and engineering would say that, hey, I want to run some custom compute on this. So we used to tell them, okay, write a bunch of Python code and then we'll run it on that. We call them extractors, ETL extractors, right? So we had a data prep phase before that, just to it was a blob, compressed, open it up, tarball, untar it, open it up, and do all of that. And then run the extractors on that. That's one pipeline. And then the second pipeline was a bit more generic. We used to take Cloud SQL, TCP, Cloud SQL dumps, and then maybe run a bunch of extractors on that. Nothing very fancy. So this is the basic context. So where's the problem here? As product managers think about, okay, let me do more and more with this data, they start asking for more and more extractors, right? Or they ask for more data to be added in those blobs that we ship. Even if you were not to do that, the fact that, as I said, we sell more hardware means there's going to be more source data coming in. So it basically says that, okay, your scale is going to keep growing. So where were we going with this? When we started this effort, at least my team, we were on track to probably hit 10 million just to do this per year. And then at some point, somebody from the city office asked, can you reduce this by 90%? I'm like, okay, if you want to give us a number, they give us a 90% number, right? So we said, okay, fine, let's go with this. Right? So yeah, why not? I mean, as they say, shoot for the stars, land on the moon kind of funda. So what was our plan? We took a engineering data-centric, data-driven approach over here. We said, okay, if you want to optimize this, we need to know what to optimize. We don't have a good measurement system in place. So I will measure, analyze, fix some things, and then keep repeating this for some time. And for this, we needed tooling. We had some tooling in place. For example, we had cost observability tooling. We were using Cloud Health, VMware's Cloud Health. We were using, I'm saying because very recently we are moving away from there, and plus a bit of custom tooling. Why custom tooling is basically because if you look at Cloud Health, I have personally, I have not looked at a lot of cost observability tools. I use Cloud Health. The thing is you can tag infra, but if it's a multi-tenant resource, you can't easily tag all, or rather you can't apportion cost to all consumers of that resource. Right? In some resources, it's possible. With a S3 bucket, multiple buckets, you can do that. But with, let's say, a compute resource that is being used for 3-4 different things, it becomes difficult. So we said, okay, well, let's use a thumb rule that if it is being used for X amount of time, 4 guys divide by 4, it should work. And it largely worked. Right? And we needed to do that to basically, again, get this multi-tenancy down. And also, we didn't want to spend time instrumenting everything. This was the quickest thing that we could do. Yeah, so sorry, this is not very visible, but the numbers and the titles are not important. But the point I wanted to highlight was that this was the output of that. This is for people who know, this is a Tableau dashboard on top of that Snowflake data. So we extracted that data, dumped it into Snowflake as well as created a Tableau dashboard. So this would give us on, let's say, if I remember, this period is a monthly cost after sort of we did some optimizations or somewhere in the middle of the optimization. So it says that, okay, we are spending about $40,000 a month. And if you see, obviously, in hindsight also, the cost is dominated by compute. The storage costs are very low, and this fits into how the cloud is behaving today. Compute is more expensive than storage, so that's what we get. And another tool dashboard that we built was, we said, okay, we have this data. How do we go about actually reducing costs? So we wanted to basically do a bit of attribution. So we started attributing cost to internal business entities. So we started looking at, okay, there is a Snowflake table. We created this, I won't say we created, we use this metric called as cost per query. This is not the cost to run that query, but this is the cost to, it's an end-to-end cost of, to satisfy this query, I must populate data. I am going to spend time and money on infra and compute to actually build that data out, right? So that includes the end-to-end cost. So cost per query is the cost to run that extractor, populate Snowflake, and then after that, actually run queries. So so it basically says that, okay, the top guy is spending about $200 a query. So it means either your costs are very high or the queries are low, right? So that tells you whom to go after. It also let us basically, again, do some sort of grouping of costs. We started grouping them by teams. We started grouping them by extractors. That showed us who the heavy hitters are over here, right? And it also showed an interesting thing. There were folks who were spending money, putting data and not using it at all. So those are what we called unused tables. So the top guy over here is spending $4,000 to populate a table which nobody is reading, right? So we got this kind of insights from this particular data. So what did we do? In the words of our CTO, he said, use it or lose it. So the people who are not doing anything with this data, stop processing those bundles altogether, right? So we just stopped it. The thing was, okay, there is no ROI in doing all of this. I'll talk about the tech aspects of those two pipelines. This might be useful for folks who do something similar. As I mentioned, pipeline number one, and this is all Spark, right? Pipeline number one, we run custom code, right? We run those extractors on that data. And the way we had structured our jobs were that the task nodes would basically run these extractors in a bunch on, let's say, one of those blobs, right? And you are running multiple such tasks, right? Spark job, multiple tasks you run. So you see that, okay, there's a flavor of Hadoop also here. What happens is if one guy is slow, he holds up the whole job, right? The long tail holds you up, right? It's not that, okay, I can finish the whole task or rather the whole app or the whole run and just because one guy is pending. So it meant that you were holding compute until that last guy finished. And that last guy was getting held up because of the way we were doing compute. We were looking at log lines one after another, checking is this log line of interest? Yes, it matches some criteria, then go extract a field from there and then write it to Snowflake. So the insight we had was that most people are following a pattern. Check for a pattern, then extract some field from there. So we said, okay, let's apply a pre-filter. You tell us what patterns you want, we'll pre-filter for you, and then you extract the columns that you want, right? So that led us, I don't have the data around what percentage of benefit we got from here, but decided to that. The second pipeline had a different problem. As I said, the size of those blobs varies and the frequency also varies, right? So the second pipeline had this thing that the size of blobs varied from 15K to, let's say, 10 MB, in some cases, maybe 1 or 2 GB. Same problem. You're trying to process multiple blobs together, right? So if you have a random mix of different sizes of blobs, you have the same problem that one task was probably looking at a lot of small blobs finished, but you're holding the cluster up now while the big guy finishes. So the first thing that we did was let's bucketize by size, take all the small blobs together, take all the big blobs together. Two buckets worked for us as a first pass. So that drove utilization for us, right? Yeah, so this is sort of obvious in hindsight. We were holding up compute, we were holding up EMR, which was running Spark for a long time. So that let us sort of destroy our clusters faster if we wanted to spin them down, or rather release infra faster, as well as let our jobs finish faster. Yeah. Yes. I won't say idle most of the time. It's just that the long tail of some long tail processing was holding up the whole cluster. So that is what we tried to eliminate. Yeah, yeah. Right. Yeah. So where did we end up with this? This is a pre-picture. Sorry, again, colors are a bit bad. We were 3/4 on compute and 1/4 on storage when we were doing this. And when we applied the optimization, we applied that in phases. We arrived at a steady state where our compute went just below half of storage. So this was done around last year, about a year back. Since then, we have also applied optimizations to reduce our storage costs. We had infinite retention. Don't know why, don't ask why. Then we worked with our legal folks to figure out, okay, how much can we reduce this by? So they told us, okay, 400 days is enough. So we basically blew away the rest of the data. So that brought down that number a bit. But that's, no, don't need it. If I have to keep it somewhere, I still have to pay for it. We don't need it, get rid of it. Okay, what else is possible? One thing to notice is that, as I said, those clusters drop a blob onto the cloud, right? And what we do is, oh, okay, 100 of them have come, let's process them. There's one fun thing that happens over here. Product managers and all don't query this every day, and they don't need that fresh data. They look at it once a month because they have to go into a meeting, or they look at it once a quarter, right? Because they have to go and show a report to somebody. So why are we spending time doing this all the time? At that point, run a job. We can process that much. So I don't need to actually go and provision a cluster and keep it around all the time. This let us take advantage of the cloud. And this is what a cloud gives you, right? It's very elastic. Spin it up whenever you want, destroy it whenever you want. On-prem, you can't do that, but yes. So we decided to take advantage of that. So we have this done, although I said it's what else is possible. We have this rolled out. This is already available to folks. We want folks to move to this system now. Another thing is, I said, we bring in a lot of, call it logs, and then look at it, right? We were not doing any filtering or any data reduction at source. So it meant that at the point of generating the data itself, we are looking at, and this is a project in progress where we are trying to reduce or rather skip only the important data back to the cloud. The bit about, no, in case I need it, send this does not work anymore. You pay for it. The third thing that we'll probably do in the future, I said we let teams run custom compute, right? So what would happen is team A has created an extractor, right? Then team B asks, okay, is there an extractor like this they have created? Let me copy it and then do something. So what happens then? Team A had a bug, team B also has the same bug, right? So you end up having the same mistake spread out. So we realize this pattern that, okay, people want a pattern to be looked at and some columns to be looked at. So that you don't implement all of this. I will framework this for you. You just tell me what pattern, what column. I will do that for you. And we can probably do that much, much more efficiently, right? One place versus 10 other people doing that. So this will get to at some point. And the rest of it is pretty much an ongoing activity, right? New EMR version comes, new options, tune it, spot nodes available, right? Go tune that. So this will keep happening, right? Okay, finally, what did we figure out? This took us about 2 months maximum, a quarter. We had this problem that we were running classic EMR. Classic EMR comes with Ganglia, and the metrics, yeah, you can ship them out to something like CloudWatch or something. You have to set it up and pay for it. So we had not done that. So we said, okay, fine. I'm not going to set up all of that to extract metrics out from Ganglia or Spark EMR via Ganglia to CloudWatch. We said, okay, fine. We could basically add job started, job ended, measure the time, divide by n, get it going. So we started quick and dirty. It worked for us. And that analysis from the dashboard showed that, okay, 5%, maybe the Pareto principle 80-20 often applies, right? Five of those extractors probably contribute to maybe 60-70% of your cost. Go after them, you'll get your cost down. That's what we did. And similarly, okay, a couple of tables are not being used, stop that, you'll get a lot of cost savings. finally, what we did was we created those nice dashboards, right? We ended up publishing that to leadership. That meant talk to the directors, talk to the VPs, and say, okay, this is what it looks like. Maybe your team is number one, number two. It basically became not a name and shame. Let's not call it name and shame. Basically became a leaderboard of who wanted to go down, right? So it became what I call as a team sport, right? Another thing that we did was whenever people started saying that, no, I absolutely need this or something like that, we have to be a bit nice about it, where we started asking questions, okay, with this data, what do you do? And at some point, some PMs started describing that, okay, this is used for a feature that brings in so much amount of money, hence I will spend so much amount of money on data processing. And other folks said, yeah, maybe I don't need all of this, right? So it basically required PMs or other business also to get on board with the fact that if what you are doing is not contributing to the org top line, let's say, then let us move the bottom line also over here. Finally, what worked well for us? As I said, we were on a time crunch. What worked well for us was that we didn't have to prepare a lot or go figure out, okay, what do we do? We understood the system reasonably well that when it came down to saying, okay, what can you do in a month or two, we knew what points to go and attack. What would we do differently? What did we miss? So we said that, okay, fine, here are the heavy extractors. And then we showed teams that, okay, you need to do something about this. They asked, okay, what do we do? And we didn't think that far. That was a mistake by us. We didn't say that, okay, if we have to help them, what do we do? We thought, okay, they'll figure it out. So this would have been probably done a bit better, where we could have told folks, now maybe you should do ABC or one of those few options. But yeah, it didn't really hurt us in the long term, but we were not prepared to help teams do better. So I think that's the end of it. That was quite quick. If there are questions, I'm open to questions. I'll be around to talk more.
So, thanks to Roland, actually, he bridges the tech with business. And it was a nice talk that at the end of all the tech that we have done in the first three sessions, he summarizes, make your tech closer to the business. Otherwise, you have a risk of extinction. Thank you very much, Roland. Okay, so I would now request Ashutosh, Srinivas, and Barada to come on stage, because this is the time we would honor the good speakers. Thanks to Mintra for the good speaker goodies. So we'll start with Roland, Smitesh, our LinkedIn speaker, Palan. Please come on stage. Speaker from Mintra. Ashutosh, can we have you on stage, please? Yeah, Ashutosh is here. Director, Reliability Engineering, Mintra, Ashutosh Sharma. Please do the honor of giving the goodies to the speakers. Yeah, Mintra speakers were left out. What